Okay, that looks like we have just about everybody. So before we get started, I have a couple announcements. Bill, you asked about the road construction earlier, or the work that you saw being done. It is a Department of Transportation project being done on 278. So there's one. Another one that came up, just some general housekeeping. Anybody missing a pair of glasses?
We can't see them.
You can't see them? We may have a winner. These right here, glasses, pair of glasses, anybody?
Get them closer.
I'm working on it.
I think those are mine.
Those are yours? All right, great.
They're my reading glasses.
Fantastic. Owner identified. And then one last piece of business before we hand it over to our next presenter. Was everyone aware that today is the 131st anniversary of the hole punch? Isn't that crazy? It does beg two questions. One, it was only 130 years ago. And then two, it took them that long to figure out they needed to put holes in paper? Wow! It's still just like sitting off to the side of my mind, like, what were they doing? Like, how were they binding things together?
They had an ice pick.
A pick? Yes, that's another option. So up next, we have an update on the solid waste management program by Dan Ferguson from DOE Savannah River. If we can, let's remember all our ground rules, and we'll give them our attention, and let's get started, shall we?
Oh, okay. All right. Okay. Okay. Well, good afternoon. My name's Dan Ferguson, and I'm going to be providing a presentation on the solid waste program there at Savannah River. And I wanted to give you all an update on where we are as of today. And so as with everything at Savannah River, safety is the number one concern. We don't do anything that's unsafe when it concerns our workers or concerns the public. And we are always mindful of protecting the environment. And of course, we're always diligent about working to remain in compliance with all the regulations and laws, especially with the state of South Carolina. This diagram is just simply to show you how radioactive waste is classified. If it's waste that comes from spent nuclear fuel, then it's classified as high-level waste. And we don't dispose of any high-level waste at Savannah River. That's all scheduled to be disposed of off-site. If it's radioactive waste and it has an atomic number of greater than 92, that is greater than uranium, then it's classified as transuranic waste. And so what that means is true waste is just simply those elements that have an atomic number greater than uranium, such as neptunium, plutonium, and that sort of thing. And so I'll talk a little bit more about the transuranic waste program in a minute, but that's all that is. And so if it's radioactive waste material that's produced as a result of normally occurring radioactive material like uranium mill tailings, that sort of thing, then we don't deal with that at Savannah River. But if it's not, then we classify that as low-level waste. And we do have a program there at Savannah River to dispose of low-level waste. This is just simply a picture of the solid waste disposal facility. And to kind of give you an idea where this is almost in the exact geographic center of the Savannah River site. This is as far from the Savannah River boundaries as you can get from any direction. And it was located there primarily because this is where all the separation areas. All the industrial facilities are right in the center of Savannah River, and this is where the low-level waste is disposed of on site. If you look back here, these are the trenches where waste has been disposed of in the past. These now have a impermeable cover over them. And then if you look right here, this is an active trench, an engineered trench where we're disposing of low-level waste currently. And then you can't see it very well here, but this is where we receive nuclear reactor components from the Naval propulsion program. These are things like decommissioned submarines and that sort of thing. We do receive these components, and they are disposed of on site. And but that's where that is. And then this is what we refer to as the low activity waste vault. And low activity waste is stored here. It was intended to be a disposal facility, but currently it's just a staging facility. Waste is stored here, but it's not disposed of here. And then these buildings that you see here and here are where we store and stage the transuranic waste before we dispose of it in New Mexico. And most of this waste, most of the transuranic waste has already been sent out to New Mexico. About 95% of it's already been disposed of. We're just dealing with like the last 5% of it, and we wouldn't even have that if there hadn't had the accident there in New Mexico. But this is the true waste pads here and here. And then these are just the office buildings where all the folks that work out there have their office. In terms of low-level radioactive waste, we do generate low-level waste on site. Primarily things like protective clothing, equipment, that sort of thing that the workers use when they're working around radioactive material. And if in order for it to be disposed of on site, it has to meet the E-area disposal criteria. And what that means is that it can't have any sort of listed waste, hazardous component waste, metals, solvents, that sort of thing. If it's just low-level waste, we can dispose of it on site in the vaults and in the trenches. But if it has a hazardous component to it, like a solvent or lead or something like that, then that material is disposed of off-site in a commercial facility. And we do, of the total low-level waste that we deal with, we do have a very small fraction of that does have some hazardous constituents to it, and that is disposed of off-site at a facility in Utah. Also, we do have a very small percentage of our low-level waste that is contaminated with tritium. And we do have a tritium processing facility there at Savannah River. And if we do have any waste that does have a constituent of tritium, it's disposed of off-site as well. And that's disposed of at the DOE facility in Nevada, the Nevada National Security Site, right here. So, this is just to show you what these trenches look like up close. This is one of the trenches, and you can just see that there's nothing really unique or special about it. It's just an open trench. It's not lined. These are waste containers that are stored in the trench, and these will eventually be covered, and this will be permanently disposed of on site. We generate about 5,000 cubic meters of low-level radioactive waste each year, but we don't store any of it. I mean, it's disposed of almost immediately, and like we do receive components from the naval reactor facilities, And then this is just a close-up of the law vault, the low activity waste vault. So, by our laws that we operate under, we're not allowed to accumulate more than 400 cubic meters of mixed low-level waste at any time. We always maintain that below 400 cubic meters. Actually, we only generate about 30 cubic meters per year, and we dispose of that on an annual basis. So this is gives us a large margin of safety, so we never approach this 400 cubic meters. The mixed low-level waste, legacy waste, you can see that we have disposed of 100% of that. So we don't accumulate this material. We are constantly working to get that disposed of off-site. And here's a picture of a mixed waste shipment ready to be sent to Utah on a commercial, it's a commercial disposal facility. And then here is the low-level waste trench. Here's a close-up. Just shows you simply the waste boxes and how they're stored and staged in this trench. And then this will eventually be backfilled and covered. And kind of repeating myself, but we have no legacy waste in storage. We generate about 30 cubic meters of mixed low-level waste each year, and our permit only allows us to store that for 1 year. So our goal is to keep that disposed of and keep those numbers down. All right, on the True Waste program, again, this is just simply waste that is transuranic waste, or waste that has an element that has an atomic number greater than 92, greater than uranium. And we do generate some true waste on site. We are currently generating true waste, and we do have some legacy waste, which you can see in this picture, from the waste that was supposed to go out to the waste isolation pilot plant there in Carlsbad, New Mexico, but we still have about right now we have about 1,029 containers, and this is what it looks like. This is a shipping container that's on its way to WIP, and this is what they call a 7-pack. And you can see they double stack them, so you can have 14 to a container. And typically what they do is they put 3 of these on a trailer, so we would ship 42 of these drums at a time. Now, not all the waste, as you can see here, not all of it is in drums. Some of it's in these waste boxes, standard waste boxes, and that requires a special shipping container to transport that to New Mexico. And this waste has to be packaged to the WIP requirements. It has to be characterized according to their waste acceptance criteria before they'll allow us to ship it to WIP for disposal. Now, we used to send waste out there routinely, and it was not a problem until they had the accident out there. But it's sort of like when you go to the airport now. You know, you're used to when you would travel, you know, you get your ticket, then you would check your bag, go to the gate, get on the plane. But then 9/11 happened. Well, it's very similar to this now with WIP. We used to routinely characterize the waste, put it on loading containers, ship it out to Carlsbad, and they were in the process of accepting, I think, 30 shipments a week. Well, they had an accident out there. They had a release. The site was shut down for 3 years, and they just recently resumed taking shipments. But because of their operating conditions and the restraints that they're put under, they only receive about 2 to 3 shipments a week. So it's severely restrained from what it was before. But again, it's just like travel before 9/11. This is the world we have to operate in now. And so this is a photograph of, these are the different shipping containers that we use. These are the containers that we use for drums. You can see there's 3 of those on a trailer. And then this is a special shipping container or cask that we use for what we call remote handled waste. It's a little bit more radioactive than the typical transuranic waste. And then this is a what they refer to as a True Pack 3, but it's a special shipping container for shipping those boxes that we saw earlier. And we did resume our whip shipments on April the 12th of this year, and we made 9 shipments, which doesn't sound like a lot, but it's considerable considering what we had to do to get ready. And we did dispose of about 55 cubic meters. Now we still have quite a bit to go, and then we are also generating newly generated true waste. But we're working now with Carlsbad. We're working with their characterization program to accelerate our true waste disposal program. And what we're trying to do is we're trying to get rid of our all of our legacy true waste there at Savannah River, so that we can be ready to then begin shipments of the transuranic blend down program. I don't know if they've talked to y'all about that or not, but there's a program to actively blend down the non-moxable fuel and ship it to Carlsbad. So we're trying to get rid of all this true waste so that we can sort of clear the decks for this blend down material. And I believe that's all. If I try to keep it kind of short and to the point, but if y'all have any questions about anything, or if you need me to go back and discuss something, just feel free.
Where do we sit, folks? Just okay. Susan, let's start with you down there.
Thank you, Susan Corbett, CAB. Couple things. Everything transuranic is everything above uranium. What about uranium? Where does that go? Where does that end up?
Well,
that's not considered true waste then. Just curious.
If it is uranium, I'm not really sure where we do.
Okay, well, let's move on. That's all I want to. So let me just make sure everybody understands the difference between high-level waste and low-level waste, and maybe I want to make sure I understand it too. My understanding of the differences is it's really just a matter of concentration of the amount of the radionuclide. It's not that there's not something of everything in low-level waste. It's just there's low concentrations of it. Is that a good definition of high level versus low level?
Susan, this is Mike. No, that is not correct.
Okay, what is the definition?
High level waste is a source derived definition. I'd have to go grab the law for it, but it's basically spent nuclear fuel and anything derived from, I think, the first cycle reprocessing of spent nuclear fuel. So anything that comes from the reprocessing of fuel and the first cycle of it and the spent nuclear fuel itself is considered high-level waste. It's not a source-derived term.
Okay.
There is effort to go change the legislation on that, I believe, that's being worked, but it's still the law that it's a source-derived term.
Okay, I'll come back to that another time. So greater than Class C waste, do we have any of that being disposed of here? Where do when we take the naval stuff, we take the actual reactor vessel? Is that in there too, or where does that go?
I believe they're heat transfer or heat. I'm not really sure, but
Okay, and then one last thing, because I don't want to get by. I know other people have questions. So I've noticed that the picture of
Susan,
I'm sorry. Okay,
sorry,
go ahead.
Maxine
Go
Max
ahead.
at DOE. I have a past life in waste.
Okay.
So from the Naval Reactors facility, we take the East Coast facility, the Naval Reactor sites at the East Coast. Hanford takes the West Coast. We also get their 2 laboratories, their waste from their 2 laboratories. Typically what comes from the submarines is the core barrels or their heat exchangers, but none of the fuel. None of their fuel comes to the site.
Does the vessel itself come?
The vessel, just the core barrel up where the actual reactor sits in comes, but not of the fuel.
Not in the internal parts?
There may be some coils and things like that, but it's not the fuel pieces and
Right, I
elements.
know there's no fuel, okay. And then one last thing, I noticed that the trenches are unlined. So, and I don't know, this has been an issue at Barnwell because the rainwater does actually come in contact with the waste while it's before it's covered. Is there any way for the rainwater to actually come in contact with the waste that's in the trench?
Well, we have a program. It's another program that I'm involved with, but it's the performance assessment program or a risk assessment program. And we look at what are the long-term risk for leaving that waste in place and burying it on site. And they are covered. I mean, they have an impermeable cover over them, and there'll come a time when we will put a clay top, engineered cover over the top of that whole thing. But there will come a time when we expect that engineered cover to fail and the permeable cover to fail. And we do expect infiltration of surface water, rainwater, into the waste material. That's thousands of years from now. And the idea is that we thought about lining those trenches, and there was some consideration towards that. But what we found, and at other sites we found this, is that when you do have infiltration into a site like that, when you model it, it sort of contains the waste material and it concentrates it, sort of, they call it a bathtub effect. But if the trench itself is unlined and gradually over time rainwater, surface water is allowed to infiltrate into the waste material, it will leach the radioactive constituents from that, but over a long period of time and at much lower doses.
Okay, thank you.
David Hoyle?
Thank you for your presentation. I know that for mixed waste, DOE had to set up a site treatment plan for its management of legacy mixed waste, and that the cycle for updating the site treatment plan is every 5 years, which was made, I think, the last update for 2016. My question is has that site treatment plan update been completed, and has DHEC approved it?
I don't know. I don't know if it has been updated. I know that we do have a site treatment plan that was recently submitted to the state of South Carolina, but I'm not sure if that's the mixed waste site treatment plan.
David, looks like Shelley's had an answer for you.
Yes, Shelley Wilson, DHEC. David, DOE has submitted an update to the site treatment plan, and I know we've been reviewing it, and I think we're very close. So I've actually seen some comments from our reviewers on it, and so so that they are working on it, actively reviewing it.
So it's in progress. Well, when it is approved, could we get a copy, please?
I certainly think so.
Thank you.
Joyce?
Joyce Underwood, CAB. My questions are with regard to transportation. First of all, the true waste. You said the other ones were commercial transport, right? So the true waste, is that commercial or what?
No, the true waste, and there was a map that showed all the DOE facilities. I don't know if y'all can put that up or not. It's the true waste is sent on DOE. They're not owned, but they're part of a program that DOE has quality assurance over there in Carlsbad. All the drivers have to be certified. All the trucks are routine. They have to be inspected continuously, and that's all. Those trucks and those trailers and those containers are used strictly for that program. They're not used for anything else.
Okay, that answers that question. With regard to the commercial transport of the other waste, I'm totally blanking on what you called it. Mixed waste, thank you, Dawn. Since those are commercial truck drivers, do they have any kind of dispensation from the Department of Energy if, for whatever reason, they have to be searched? Because there's waste in them?
Well, those are all those trucks and the companies that accept that waste. Those are all commercial facilities, and they have their own drivers. And if they're, you mean searched by like
Department of Transportation? Like if they go through a weigh station and they're overweight because somebody's scale was off, if they get in an accident and the police have to see what's in the truck, that kind of thing.
Well, we still share a legal liability for that waste, even though it's on their truck. And so, if the truck is searched, it's still our waste, even though they have taken it off site and transported it to their facility. We still own it.
Right. I guess my concern is for people who are not experienced with waste being on a truck with waste. Like, is there a paper they get to carry with them that says, hey, wait for Department of Energy to come help you?
I think you're trying to ask, can they crack open the
Yes.
trailer and peek inside, or do they
Yeah.
know not to do that?
Yeah, that's my question. Thank you.
No, they have guidelines that they follow as far as like maintaining custody of the waste, and they don't have the capability to tamper with the waste. It has it's like a chain of custody program that once the waste is sealed at the site and put on a truck and transported, if it arrives there with the seal broken, if someone's gotten into the waste, then they send it right back.
Okay.
So,
Thank you.
All right. Thank you, Joyce. Mary, is that
Yes.
yours down there?
Mary Woodward Cab. On slide 3, there's an acronym that I'm not familiar with that isn't on your acronym list. What is NORM?
NORM stands for Naturally Occurring Radioactive Material.
Okay, thank you.
All right. Anybody else? Oh. Yeah, Mary, is your card still up? Shelley, your card is still up. Do you have any further? Okay, well then, Shelley.
Yes, I got a little bit confused in relation to Susan Corbett's question, so just wanted to try and clarify. So when you have the low-level waste disposal and there's the open trench and you place a low-level radioactive waste container in the trench, is there a cover over the top of that?
There isn't initially. The way they
Right.
Yeah.
Are you talking about a long after the cell is closed and you put a cover over the top?
Yes.
Yes. So, but that's different than operation. So operation, yes. I just wanted to clarify that during operate, and that's, to be honest, that's typical of what I've seen around the nation. I understand. I just wanted to make sure it's clear.
Questions? Any further questions from around the table? Okay. Dan, thank you very much. Up next, we have Randy Clendenning. He's going to talk a little bit about 235F deactivation.
Good afternoon. As they said, my name's Randy Clendenning, and I'm the DOE program manager for the risk reduction activities that we're currently engaged in 235F. What I plan to do here today is to run you through what we've done since the last time that I briefed the CAB, and then update you on some of the things that are coming in the coming year. These are I don't want to get too fancy and screw this up, but these are both pictures of 235F. It's a two-story, very, thick, 15 inches or so, concrete windowless building that these things are, that the PUF facility is contained in. And on this slide, there's 235F, and the main product that flows down into here is, for the activity that I'm going to talk about today, the waste product is primarily transuranic waste, as opposed to low-level waste. So a little bit of background. Some of you may have seen this before. 235F, the building itself has had numerous missions over the years. The actual facility that we're talking about when we talk about the risk reduction is a facility called PUF that took the plutonium-238, manipulated the material, if you will. It was high-fired, heated, and then it was ball milled to make it very small. And then it was pressed into a configuration that was eventually turned into small pellets that were used to make power assemblies, I guess, for satellites, for NASA missions. Mostly deep space missions. Cassini had one of the heat sources built from our material on it. The material that's in the PUF facility was last measured in 2006. I'll get to a little later. We're currently redoing that to update the numbers. At that time, we estimated there was a little more than 1.5 kilograms of 238 that we estimated was in there from the measurements. The problem with that is, in a seismically induced full facility fire accident scenario, the calculated unmitigated dose is about 12,000 rem to the co-located worker, the people that are in the immediate vicinity of the building, and about 14 rem off-site. The building has been maintained in a surveillance and maintenance mode since they've ceased operations there, which was in the mid-'80s for the PUF facility itself. There have been some other things that have been done in the facility since then, but I believe it's 85 maybe. Anyway, the mid-'80s, they ceased operations in PUF. The objective that we've stated in our implementation plan to a recommendation we got from the Defense Board is to reduce the on-site dose to the co-located worker to less than 100 rem by reducing the plutonium-238 levels in PUF. We call that the MAR, the material at risk. And then at a point where we think we've achieved what we can get done, what we can reasonably get done as far as the reductions, we'll initiate a discussion with the state to negotiate a final end state for the building. I'll go through this. There's some updates I need to make to it because I was optimistic when I put this together, and by the time today came, I was overly optimistic. The first one, we had planned to complete the mechanical and electrical isolation of cells 3 through 9 by now, but it's an old facility. You've probably heard over the years with presentations that we think we know how they're wired, what's in there, but we take a very deliberate approach to anything that we go do because sometimes you get surprised. That happened here. Early last week, late the week before, when they were going through this, they found 4 wires that weren't on any prints or drawings, and then they had to go deal with them. So that's what they're in the process of doing. We expect to have that done the week after Thanksgiving. We've completed removing the outer shield windows and cleaned the inner windows of cells 1 through 9. I've got a picture a little later where you can kind of see what that looks like now. When we started this, the lighting in the cells wasn't functional, and you literally couldn't see what was in there. So it was very important to get those out so we could get some light in there so we could see what we were dealing with. We did establish the lighting. We've completed measurements. I talked about the characterization. The new measurements that we refer to it as enhanced characterization of cells 1 through 9. I'll get to in our plan for next year. There are wing cabinets that come off of some of these cells, and I brought this, but I know you can't see it, but I have a slide of it later. On cells 1, 3, and 4, there are cabinets that come off the back of those. We still have to do the characterization of those. We're just done with the glove box cells themselves at this point. The window remediation of the wing cabinet windows is not complete. We have cell 1 wing cabinet windows remaining to be remediated, and we should have that done before Christmas. And then we also have demonstrated the use of a vacuum that we had fabricated for use in the cells. We got it in the cell, used it, vacuumed up some stuff to make sure it would work, demonstrated that we could change out the filters in the vacuum, and that was all done successfully. The key things we plan to do in this fiscal year is to complete the measurements of the amount of material in the cells. That's predominantly the wing cabinets. We expect to have that done by the end of January-ish. Well, we expect to start in January. We expect to have it finished around the end of March, and then have a final report for the whole PUF facility issued in the May timeframe. We expect to complete we plan to complete the mechanical isolation of cells 1 and 2 and the wing cabinets attached to the back of the cells. We expect to have that done by June. And then the department recently approved a revision and update to the safety basis documentation, the deactivation basis for interim operation, and the contractors beginning the implementation of that, and that should be done March, early to mid-March sometime. So, and that is what I was talking about. That's cell 5, 4, and 3, and that's what they look like after we've remediated the outside windows. This area here is called the shift operating bay. After we've remediated the windows and put some light in them, and then we put up a fence around it just to keep somebody from inadvertently introducing something into that space, because we just assumed they didn't do that. This is also what it'll look like. We've removed the manipulator outer control arms off of these 3 cells and blanked them off. I believe probably on the next picture you'll get okay, this is the picture that I was talking about, and let me go back to what I was updating you on, what we've accomplished. We're working on completing the mechanical and electrical isolation of cells 3 through 9, and that is 3, 4, and 5 is what we're doing now. We've completed 6 through 9 on this side. The facility, this is called the shift operations base. The material would come in here, and then it would be processed and go this way, and there's a tunnel that then moves to the other side, and it's processed and goes down this way. I don't think they ever used cell 9 for anything except storing things. There wasn't any active process with the material that was conducted in there. But as I mentioned, we removed the outer shield windows. These are the outer shield windows right here. We put the lighting in. And then these are the wing cabinets. There's 2 wing cabinets on cell 1. There's 1 wing cabinet on cell 3 and 1 on cell 4. These are well, that's the back side of the cell windows. The yellow windows here are the wing cabinet windows, and these have been remediated, and we have the ones in cell 1 to complete yet. And we demonstrated the vacuum. There's a port here where you can introduce things into the cell. So we introduced the vacuum into cell 6 and worked with it here to test it out and make sure it could vacuum stuff, and also in cell 7. We try to use these. The way the activity works in these cells is it's lowest here and it gradually gets higher, and of that 1.5-ish kgs, most of it is here. These cells have very little activity in them. These two are relatively low, but we use them to practice our techniques. If we take tools in, for example, there's a welder in here, some a chain fall. So there's things we can do to practice in there before we get over to the areas that are a lot higher in activity. So if something, were to go wrong, this would be the better place to learn from it. So this is the last picture, but this is cell 1. This is cell 2. There's 2 more windows here you can't see. There's 3 windows on cell 1. That's the last one. This is cell 2, and that is cell 3. And then you can see with the manipulator outer control arms attached, that's what it looks like. This is an old picture. It's not nearly that pretty anymore. That's basically my update as far as what we had. Are there any questions? I do have a poster. I know you can't see from where you sit, but I'm going to leave it so it'll be there if you want to look at it.
So let's start. We haven't started with Dan yet, I don't think. I know we've gotten to him, but we'll start with Dan.
Thank you. Dan Kaminsky, CAB. Just a couple of questions. Thank you for pointing out the lowest to highest levels. That was of interest to me. What quantity needs to be removed to achieve the goal of total catastrophic issues where it would be under the 100 milligram?
I can't give you a gram number. When the nuclear safety analysts go do that calculation, there's a lot of inputs that go into it. One of the inputs that went into it was combustible material. We've gone to great lengths to remove all of the transient combustibles, the stuff that can just be picked up, hauled off, or walls that were in there that weren't structural that we could take down and remove. We also went through an exercise of electrical de-energization of things that were in the facility. There was for example, a shop that had it was a big grinder, but it was on a stand, portable saws, things like that, and all of that stuff was removed to reduce the chance of a fire from any of that stuff as much as we could. Okay. So, but I can't give you a gram number. I just don't know. It's very small, though.
Okay.
A little bit of this stuff goes a long way. It's a very bad radionuclide when it comes to hazards to people and things.
The reason I ask is because as you go up the food chain of what's the lowest impact cells to the highest, obviously once you perfect your process, the sooner you can get the highest down, the bigger bang for your buck. Do we understand how many grams are in like cells 1, 2, and possibly 3 of the 1.5?
Yeah. So from the 2006 results, there's about 16.5 grams in cell 3, 4, and 5 total. If I'm reading this right, yeah. That help?
And is the brunt of the 1.5 in 1 and 2 then? Is that?
Yeah, there's very little on the other side. For example, according to the 2006 results, we had about 1.8 grams in cell 6, and the total, 1.78 in 6, and the total of all the cells on that side was 1.8. So almost all the activity on that side is in 6, and there's very little of the total activity there. And our plan was to start where the hazard and the activity was small and work our way into the bad stuff so we could get better as we go before we get there.
Okay, it would just seem to me that it could be a benefit to understand what you need to get that down to. Because obviously it's just the law of diminishing returns. As you attack very small amounts, it gets more and more expensive to get the tiniest of the particles collected. And if you can get it to a point where you've got the massive amount collected and remediated, then what's in residue is not insignificant, but less of the risk, and I would hope that it would get you under your 100 millirem goal.
Well, at the risk of, and the 100 rem is a goal. Until we get in there and start trying to take this stuff out, we really don't know how much of it we'll really be able to remove. I mean, we could end up at a point of diminishing returns. You can throw more effort at it and you remove very little. But it's one of those things where you don't know where that point is till you get there.
Michael Michelinas, DOE. Let me try and help a little bit with this. Dan, you're absolutely right. We're very, very much aware of the fact that there's the diminishing returns curve with cleaning out these cells. So was the Defense Board. But when getting to your question on how much do you have to get out before you get below the 100 rem limit for the co-located workers that we use, those numbers are very small, and it's highly dependent on, excuse me, on the uncertainties with the analysis. The scans that Randy mentioned at the beginning that gave us the gram quantities that are in there, the kilogram quantities, have a large error associated with this. So there could be up to the 1.5 that he mentions, it could be less. We're part of the implementation plan for the board's recommendation is to go in and using by pulling out those shield windows and putting in more sensitive detectors, we can actually get a better, we can eliminate some of that uncertainty and figure out what's really there. Even if it really is close to the 1.5, how dispersible is it? The nuclear safety analysis didn't try and quibble and cut corners. It just assumes, hey, the fire occurs, it's like a parking lot scenario. Nothing's held up in the cell, everything's released. It doesn't hold up in the building, everything's released. So that drives very small numbers. What the department realized very quickly when we were responding to the board was going after the material at risk wasn't the right way to go drive the risk down. The way to drive the risk down was to decrease the likelihood of a fire that would cause that release. And as Randy said, we went at great pains to remove combustibles throughout the facility, air gap, electrical connections within the facility so an earthquake wouldn't create the arcing and sparking that fires it. But even if you removed all of the plutonium in these cells, there's still some hold up elsewhere within the facility and in a couple locations and within the ventilation system. So it's the entire facility's accumulation of material that's there. We really need to get in there and decontaminate it. What's in there can be fixed too. We're looking at possibly using an affixing agent. Maybe that's removable, maybe it's not. Maybe that's part of what we would define as an end state to the state. We're looking at all of that as we progress forward. But first we have to experiment with what techniques will successfully get in there and let us work on that. And we've been using the cells, as Randy said, on the other side to learn make our lessons learned. Because if something's going to go wrong while you're working at a tool goes in and it's not the right size or it doesn't work the way you think it's going to work, you want to find that out on the clean side. So that's kind of the philosophy of what we've been doing. I hope that answers your question.
It does for the most part, yeah, thank you.
Dawn Gillis Cab. The assessments that you've been doing so far on how much plutonium is actually in there versus the 2006 analysis, have you been able to get rid of that error bar at all? Are you not close enough that you can say that there's the error bars instead of being 200% or only 50% error bars?
What we're finding in general terms is about, because it varies from cell to cell, but we're finding about a little less, but about the same amount of material, but the precision of the measurement is much tighter. And when the nuclear safety analysts go do their calculations, they take the error of the measurement into account. So the more exact and precise the measurement can be, the better that it will work when we go to do the calculations. So that will work in our favor. The other reason, one of the big reasons we went and wanted to redo the measurements before we did this is I guess what I was saying about how do you know that you've gotten as far as you're going to be able to get. Well, you have to know where you started. So we wanted to go get another series of measurements for that purpose also, so that we know where we started, and when we think we've hit the point of diminishing returns, we'll use the same equipment, so it's an apples to apples kind of measurement, to go look again and see what we've been able to get done. And we plan to take these measurements take a while, several days, and then some time to do the calculations and come up with numbers. But while we're in the process of removing things, particularly in like cells 1 and 2, where most of the activity is, we anticipate taking a pause, taking some measurements to basically, to see what we have accomplished as far as removal of the material.
Well,
I don't know a
thanks for that
percentage of improvement, though, for you.
Okay, that's good information, but that wasn't my question. My question is, right now you say you think there's about 1.5 kilograms in the whole facility. Rechecking all of that, are you finding that number is still close to that 1.5 kilograms, or are you down to 600 grams?
As I said, as we go along and do these measurements, we're finding numbers that are roughly the same as far as the quantity of material in there.
Okay, all right.
The difference is the precision of the measurement is much better. So it gives us a better number. Having said all of that, most of the materials in 1 and 2,
right, and
we're not done with those.
Yeah.
Well, 1, 2, and the wing cabinets.
Yeah.
So the locations where we believe, where all of the other indications tell us most of the material lives, we're not finished with that part yet.
That's why I was asking if you were far enough along with that to get the better, but apparently you're not. When is that expected to be completed?
We expect to have the wing cabinets done by early next year. I believe we start in January, and I believe we're planning to have that done by March. Yeah, we should start in January, have it done in March, and then we should have the final report, and SRNL is doing this work for us. We should have the final report of the whole facility by May.
Okay, and I'm sure we'll be updated.
Yeah.
Thank you.
Tom?
Tom French, Cab. Thanks, Randy. That was a good presentation. I have one simple question. In the accident scenario, the dose seems super high to me. And is that from heating the material or dispersing the material into the building?
Both. So let me tell you a little more.
Okay.
As Michael indicated, when they did the analysis for this, the unmitigated release, it essentially presumes that when you have the earthquake, the entire building evaporates instantaneously. The complete inventory of the building goes up in a plume all at once.
Okay.
So you've got a 2-story building with about 15-inch thick walls of concrete that you don't use in the calculation as affording you any mitigation. So yeah, it's from heat, and well, the heat's what drives it. I mean, you got to have heat or it's not going to go anywhere.
But the heat and the dispersal, right?
Well, the heat drives the dispersal, yeah.
Okay.
Susan?
Susan Corbett, Cab. So I guess there's really no opportunity to just entomb this building. I mean, that just wouldn't work. I mean, is 238, is it really flammable? Is that part of the reason you don't want to, it just kind of spontaneously combusts, or would it need some sort of catastrophic event to make it combust? And why couldn't you just entomb the whole thing and leave it? I mean, it's just relatively short half-life, right? Is that not an option?
It does not spontaneously combust. It gets extremely hot. That is an example of it. It's not naturally red colored. That is heat.
Yeah.
Just from the material sitting there. So it can start a fire.
So it can spontaneously kind of do something crazy.
Plutonium-238 will not spontaneously combust.
Okay.
If there's things around it that will burn, it can start a fire.
Okay, well, I guess that goes back then. Why couldn't we just put a sarcophagus over it or something like that? Would that also not withstand an earthquake? Is that the problem? I don't know,
SRNL has done some analysis, and I may be approaching 10 years old now, but when they went through their calculations, it's about an inch of paper, but one of the takeaways is that if you fill these things full of grout, it will not afford you the kind of immobilization that you would need over the thousands of years that they use when they calculate things and negotiate with the state. That's not my expertise, but you can do that, and it won't necessarily, it won't do enough for you. And the other difficulty is, I've been told that when you get over into the closure space, we, in an operational activity, which is what this is, cannot do anything that's considered an irrecoverable action. And if you fill that with grout, it is irrecoverable.
But aren't we going to entomb it anyway in the end? I guess the state will have some say in that, but is that ultimate?
What we end up doing will be negotiated with the state, but if we entomb it now and then learn we have to remove something, it's too late.
So, Michael Michelance, DOE again, that is an option, Susan, that we're looking at. The implementation plan that we put together and sent to the board had us first go in and understand, as Randy mentioned, what's the baseline starting levels above from the 2006 assessment. We'll clean out as much as we can without going to Herculean efforts to clean out the Aegean stables and measure how much of a reduction we've got. That'll give us a sense of how efficient the cleaning process could be. Part of that could be some fixatives like and I'm just going to make up like a latex paint that you could paint on the inside and affix it to there, but that would still be removable. It wouldn't be the irrecoverable action that Randy talked about. But once we reach that point, we feel that we've hit the diminishing returns on what we can pull out, and we've fixed as much as possible to make it less mobile. One of the solutions, the final dispositions, then could be negotiated with the state to entomb it in grout and fill it up, much like one of the reactor buildings. That is on the plate, but we're still several steps before we would reach that point in the decision process.
And we're not, as Michael mentioned, we're not waiting till we get there to be thinking about other options. We fund the National Laboratory to do some R&D for us, and they currently have a fixative that is not flammable. But they have to do some testing to see what kind of radiation degradation will be involved. So they're working on that and trying to find a fixative, either commercially available or of some type, that we can use when we get to that point if we want it. So that'll be an option. And if we apply a non-flammable fixative, it could turn out that that's enough and we don't need to deal with grout. We just don't know yet.
Joyce.
Joyce Underwood, CAB. Can you put this back up, please?
Sure.
Thank you.
Let me get the direction right. I digress, but there's the measuring equipment. There we go.
Okay, so we saw photographs from one direction of cell 1 and 2, and then from the other direction of cells 5, 4, and 3. Can you show me with the laser pointer which thing on there is the wing?
Oh, sure. So this is the cell. What is the glove box itself, these things? This is the wing cabinet.
So the middle part is where you stand.
Out here is where you stand.
Okay, thank you. That is very helpful because I had it completely backwards.
Okay, so this is where you would, this is where the manipulator control arms hang. Out here, there was a picture of those, I think. Let me back up. There. It's the last one. There. So this is that middle area that we call the shift operating base. So the operators would typically be in here to work with the manipulators and things. However, there are also gloves and access points into these cells from the backside. These are called maintenance rooms, west maintenance, east maintenance. So if they had to do work, or if they had to work in these wing cabinets, they would have to do it from this room. And there are glove ports here, and that's why the windows are there too. But predominantly, most of the work would be done from here, but there's also a need to do some work back here in the wing cabinets, or if you have a need to get to the back side of this for some reason.
Okay, that's very helpful because I had the hallway somewhere completely different and I couldn't figure out how you could get it from the wing into the cell. But now I see it's in the middle.
In fact, in cell 1, it's actually introduced into the wing cabinet.
Okay.
And then it moves this way, and then it'll go down here. It'll come out the wing cabinet. Some of the work is done in the wing cabinets, then it'll go back to the cell, but it flows that way.
Okay. See, I thought the work was being done in the middle part where you stand. It was not going to work. My other question is, with this plutonium, this is not something that can be downblended, right? Because it gets hot, I guess.
I'm not the expert on that, but I would think doing anything like that, the decay heat from it would be a problem.
Okay, thank you.
And I didn't say it this time, but in one of the other presentations that I've made to the cab, it's a particularly nasty isotope. I mean, if you take the common thought that of the radionuclides out there, plutonium is one of the worst ones to deal with. Well, of the plutoniums out there, this is one of the worst of them. And then we went from there and engineered it to make it even worse. We high-fired it, which makes it almost insoluble, and then we ball milled it down to such a fine powder that one of the things you have to consider is whether or not it'll go through a HEPA filter.
Oh, okay.
It's bad.
So, Mike McElance, DOE, Randy, I just want to differentiate between two things. You showed a picture up there where the plutonium in a solid ingot was glowing. That's a particularly dense configuration. It's been sintered, it's been put into a very small thing. The materials we're dealing with in the cells are not glowing red. It's a powder, it's not as dense, so the heat dissipation, the heat generation isn't going to go heat up the plutonium matrix the way that thing is glowing there. So one of the things I don't want anybody walking away from this meeting is that, hey, cells 1 and 2 there's actually red glowing materials in there. There isn't. Correct me if I'm wrong, Randy, but when I took a tour several years ago, those cell windows aren't hot and we're not seeing glowing embers. But the materials, Randy said, from a dispersibility, from a dose perspective, if it's ingested, it's not good stuff, and it's very hazardous to just leave unmitigated.
Yeah, there's nothing in there that glows red that you can see. But when this facility was in production, they would take the 238 in a concentrated form like that, and they would press it into spheres. In fact, that was one of the evolutions that was done in the wing cabinets. In the wing cabinet on cell 4, there's a press in there where they would take this and they would press it and encase it in graphite into a sphere. And then when it moved over to cell 6, I said there was a welder there. They would then weld it into an iridium capsule, and then it would be cleaned up, and that would be the product that would come out of there. And then that's what the site did, and then it was shipped elsewhere, and the RTG, the radio thermoelectric generator, the power pack, was constructed elsewhere at another DOE facility. Mound, I believe.
Jim Lyon. Would it be fair to say that this is kind of a worst case isotope scenario? That if you really have a problem, of all the problems that could develop, this might be among the worst you could possibly have?
It's probably the worst isotope to deal with. But having said that, physics works in our favor. It has a short half-life compared to a lot of the other plutoniums. I mean, the half-life is 89 years. It's 88.8, I think.
Yeah, I appreciate that. Yeah, but
and there's also not much of it. But like I said, a little of this goes a long way.
Thank you.
Okay. Any other questions from around the table? All right. So we're in one of those rare situations when you're running a little bit fast. So
I did my part.
You did your part for sure. So are there any questions from the? I know, but are there any questions from the public? We have time to entertain one or two. No? Randy, you're free. Thank you. Okay. Up next, we have Zach Todd, who's going to give a brief on the E and performance metrics.
All right, so hello everyone. As James said, my name is Zach Todd. I'm a planning analyst within the Office of Integration and Planning, and also the Strategic and Legacy Management point of contact. So I get to work with Bob and David Hoyle, kind of coming up with the work the environmental management cleanup performance metrics. So kind of coming to the purpose of this. Originally, this was kind of come up to about like the CAB wanted to have like situational updates on the overall progress of the EM mission on the site. So I don't want to say we developed these metrics for these. There's a lot of things that come up with these metrics, environmental milestones, like capabilities of facilities and stuff like that. But we started sharing some of these with the CAB several years back when Rich Olson was still doing this. So really the intent here is to provide like just kind of like a one-stop shop, a compilation of the different metrics year to date, or for the past fiscal year, rather. So it's not a real deep technical dive on a lot of the issues. We got some of the experts in the back, some of the program owners back there. If there are any of the questions that kind of come into that, we'll be able to answer them. But that's really not the intent. And again, it's just like a one-stop shop. Hey, here's the numbers. This is what we thought we would do this year. This is kind of where we are, and really the reasons why, in a very broad concept. So moving along, you know, the EM mission at SRS started back in the mid-90s. And then since then, like from that, we developed these performance metrics. And like I said, these weren't necessarily developed specifically for the CAB. There's a lot that goes into all these developing these performance metrics. I want to say the base of them are like, you know, regulatory in nature. There's a lot of other things that go into it, like, you know, capabilities of facilities. We know we have this new facility that's coming along, so we're going to be able to produce X amount. So all those things kind of factor into what we think our projection is going to be for that coming year. So, and these are the kind of the ways that we kind of categorize the categories that we put these different metrics. They should look semi-familiar. They generally fall along the lines of PDSs, and we kind of broke them down a little bit further. But these are the different areas and stuff that we'll see the metrics. So some of these will actually look very familiar. You actually saw for the solid waste, you saw 2 of the slides today. Dan Ferguson actually went into them. They're in here too. So again, like just that compilation of like, hey, year to date, this is our previous fiscal year, this is kind of where we're at. So how did we do in fiscal 17? Kind of as always, it's a mixed bag. You're well aware of the issues that we've had in liquid waste with the melter and how that affects some of the outputs, and you'll see that in the slide. But generally, outside of liquid waste, you know, we met all our targets, and you'll see that in the upcoming slide. So the challenge, you know, when the melter went down, it really causes an issue. You know, it's an entire outage of that system, and there's always like Savannah River site, you know, so many of these systems are interdependent, so it affects other things. So, you know, when your liquid waste goes down, it's not just the canisters, it's also salt stone and, you know, hey, the amount of gallons that we can process and stuff like that. So there's all these interdependent processes, and that's really how it affects. And one thing in one area can affect the entire site in some ways. So despite some of the challenges, we still had some highlights. You know, we're still able to vitrify 52 canisters, which, yeah, it wasn't our target, but, you know, still, like, it's progress, right? So taking some of the bad stuff and make it into a more stable is a good thing. So, and then, you know, you get realize some of these are kind of ongoing issues as well, but these are the things that, you know, this past year we were actually able to accomplish. So moving into liquid waste, this is one that, again, for the melter, it really kind of put a damper on what we were actually able to do. So you can kind of Target of the additions, the new receipts, what we were anticipating. You know, I guess, you know, based off your perspective, you can kind of derive whether that's a success or a failure. But that's kind of where we're at for this year. Inventory, kind of, again, based off of those, we're just a little bit too short of our target. Nuclear materials, really not too much of a change, or not too much of a difference. Our target hit our actual perfectly. And lastly, soil, water, and facilities. And this is predominantly, if I'm not mistaken, D-area ash basin. You can see the picture up there. Our target was 3, and we actually completed 3 as well. And then you'll see the cumulative to date and then the end state. So, hey, coming to the summary, we will continue to monitor these and track these in these little buckets that we do, and we'll continue to brief this like kind of a once a year summary to the cab. Any questions? You got your acronyms and stuff.
We have one, Dave Ovakis.
Dave Ovakis, Cab. Zach, thank you very much for the presentation. Who sets the targets, and what's the process for setting those targets?
Yeah, so I talked to Gene Ridley a little bit about like the document that you showed me. And I'll give her an opportunity to speak here in a second on that specific issue if you're wanting to kind of continue. But there's a whole host of things that kind of play into these. You know, DHEC, the state, you know, EM, everyone, or a lot of people have different says into this based off of like, you know, environmental regulation or milestones, what we're trying to get to, you know, new facilities coming online, and as we increase capacity, that's going to have an effect on what these targets are. So there's a whole range of things that go into it. I don't think there's like one concrete answer that says like, hey, this is where you're going to get this target from.
Does EM have input into the target setting, or does the DOE have input, or is it all SRS at the SRS level?
Mike McLannis, did you?
We do, and headquarters. Dave, to answer, Mike McLannis, DOE, to answer your question, both. The site sets what we think we can with our budgets, but that's also negotiated with headquarters as they set the budgets. We put our budget request in and what we think we can do, and we propose. When the budgets don't come, when Congress gives us something different back, those all have to be renegotiated, and headquarters has a large voice in what goes up to Congress and what comes back from Congress.
And I know DOE is responsible for producing an annual performance report, annual performance update, annual performance plan. Do these goals and measures, do they roll up to what we see at the EM level and the DOE level?
So I'm getting some head nods. Yes, but
yes, they get rolled up into where for EM, where their performance reports that report out as EM or DOE as a whole. Ours are just one stream going into there.
Thank you.
Let's go over to Larry.
Thank you, Zach. Larry Powell, Cab. On your actual versus target on liquid waste on the canister production, when understand that you had low production. Yes, you had low production there because of the malfunction of the melter. On the next slide, you had low production for FY17 for the saltstone. What was the reason for that?
It's really the interdependencies. Jean, she popped right up, so I'm going to let the expert talk on this. But
Jean Ridley, DOE. The saltstone went down the same reason. When the melter went down, we could no longer process some of this material through ARP MCU, and so we couldn't fill tank 50, which then again couldn't go to saltstone. So.
Thank you.
Jim?
Jim Lyon. How much of this is budget driven and how much of it is Having been a long time in the Department of Defense, and, you know, a report like this, you'd have people jumping out windows or you know, murdering messengers and things, and and no one accepting responsibility at a higher level for what they did or didn't do. And I just wonder, even with systems failures, you know, is the budget adequate to take care of that, or was money having to be diverted from something else to make up the difference?
Yeah, so I'm not going to answer your question directly, but so budget does have an effect on these things. You know, Mike McLandis just mentioned that as well. As far as like percentage, like a correlation coefficient, I don't know. But like there is a degree of dependence on budget. You know, it takes people to do this, it takes materials to do this, it takes a lot of things, and all that costs money. Now, like this year, how much did budget affect us? You know, again, I don't know. Like, could that have been prevented? You know, there's probably an argument on both sides, but to kind of sit there and say like, you know, it's all budget or it's all like a system failure, it'd be pretty tough.
Well, all of this, you know, all of this leaves you with a deficit to be made up in future years. But, you know, as I understand it, your budget's going to be less. And I think that presents a problem to the organization here to get the job done.
No, absolutely. You're not incorrect. It's a challenge for sure, and we'll have to continue to find ways to make up that deficit. If not, you know, we kind of go into like alternate courses of action, try to figure this out.
Well, you know, sooner or later, you know, if it goes into the next year, then you hit a critical mass of, you know, pushing it out another 10 years or 20 years or something like that. And because you just can't, your facilities can't possibly handle, even if you were at capacity now, or get up to your design capacity to make up the difference and take care of the overage that you're carrying from years ago, or this year, I should say.
So, Mike Michelanis, let me help you out with that a little bit, Jim. And let's work with the liquid waste example that we were just talking about. In this case, when the melter failed and reached its end of life, pretty much, if you remember the gear chart that SRS showed you, the whole liquid waste system kind of comes to a screeching halt because you can only go so far. What happens then is that we were planning on an outage in a future year where the production levels would be low, like what we got this year. So we basically pulled backwards the production for that year. Let's say, I'll just make up a year, 19. So we're taking the hit in low production in 17 and 19. So we just need to get an extra 2 years out of the melter, and you'll never even notice a difference at all. So it comes out, my point is it comes out in a wash at the end. Where equipment failures like this happen. And when we work the budget going up to headquarters and coming back again, we try to negotiate things that we can, that are feasible and accomplishable, because as an executive running a program, you're right. I don't want to have to report up to the assistant secretary as to why I didn't meet his or her targets, which he or she was dependent on as well. And in the complexity of a budget process where Congress actually passes a budget, it gets even more complicated when you're running under a continuing resolution scenario, because which budget do you use? The House mark, the Senate mark, the President's request, or something different? So hitting those targets, everybody knows it's a bit of an art form, and usually when we negotiate these goals, they're pretty close to what we think we can actually produce given some uncertainty. So we don't find ourselves, unless we get into an equipment upset like high-level waste melter, where you have a significant pertinence to being able to reach the targets.
I really do understand all that, and I sympathize with you. But if they don't give you the money, you know, this stuff just continues to build, and we don't want it to build.
Correct, but Congress has a number of competing priorities nationally, and they understand that when they apportion the budget to the Department of Energy versus the military or other domestic needs.
Well, there was a time when I was happy when you didn't get it, and I did. But however, now I want you to get it, and I don't care if the other guys get it. So, but it does seem to be a major causation here. And you can expect some failures in the future, even though I think this is a very well-run facility. Thank you.
Bob?
Yes, Bob Dorcab. Zach and Mike, talking again about this liquid waste vitrification process, as I remember from earlier this year, it was my understanding that the melter went beyond its normal or its predicted useful life. You guys actually got a number of extra years out of the original melter, which saved the taxpayers money, which allowed you to process quite a bit of liquid waste in a vitrification process. So there is an ebb and flow. I mean, obviously the melter has to work. At some point, the melter did need to be replaced. And the way I remember it, it was kind of a planned event. It wasn't an unplanned event, although you were targeting a higher amount than you could actually vitrify.
Sure. Mike McLean, DOE. No, you're correct, Bob. We were watching the melter. We were expecting it and knew it was reaching its end of life, and it was not completely unexpected when the decision was made to shut it down and enter an outage. If you looked at the targets and the plans back 20 years ago, we'd be operating 2 years, taking a 6-month outage, so we'd be hitting one of these low production years every 3 years. That's how but it's all about what can you do for me lately? We've built those efficiencies. We recognize the equipment's going to run longer, so now the expectations have gotten higher and higher with as you get more efficiencies and more time operating these things. So yeah, the bar, when you have a success, usually the bar goes a little bit higher and says, okay, now how high can you jump?
Doug Howard Cab. Mike, I got a question for you. During your time period here, has the Secretary of Energy ever been out to visit the plant?
The current secretary?
Yes.
No.
Not the current, but
the current secretary is not, but previous secretaries, yes, they have.
Okay. Now, when they come out and other high officials, do you all brief them on the issues and the problems that you're having out there?
There's always an opportunity in the one that when Secretary, I'll speak from the time when Secretary Moniz came out here when I was here, and yes, there were a couple opportunities. He goes to all the key and major facilities. He gets a tour of the condition and what's going on. He'll have an opportunity to listen to the contractor about the successes and some of the challenges they face, and he'll also have meetings with the federal staff as well to get the federal perspective on what's going on. So yes, there's ample opportunity, and Secretary Moniz took advantage of that.
Thank you. Great briefing.
Yeah, let me just add to that, Terry Spears. Whether the secretary, the current or the previous secretary, whether they come to the site or not, they tend to be involved with our headquarters colleagues up in EM with respect to budget development every year. So they really, I think, make an effort to understand what's going on out in the field and what the needs of the department are, to help communicate that within the administration so that, the budgetary needs around the complex can be appropriately addressed. So I don't want you to get the impression that since the current secretary hadn't been here yet that they're not involved. They are very much involved. In fact, there are briefings going on with respect to FY19 currently to help, and beyond, to help set the stage for the appropriate budgetary decisions to be made within the department before they ever get out of the department to the OMB or to the Congress.
David Hoyle.
David Hoyle, Cab. On slide number 12, for newly generated mixed low-level waste, you indicate that that the accumulation of mixed low-level waste is not to exceed 400 cubic meters at any time. Can you explain that limitation? Is that something that's voluntary or regulatorily driven?
Yeah, so I know this was a question last year, and at that point in time, we had an answer.
Let me help you on that. Zach, you're getting a lot of help from the audience here. So
yeah.
Phoning a friend is working
there
for
we
you.
go.
Listen, Terry Spears with DOE. I'll address that if you don't mind. At least I can start, and Jean can follow up if she'd like. But I know, you know, once we eliminated a great deal of the legacy waste at Savannah River, we wanted to ensure we put forth expectations from the department locally to avoid building up new legacies of undisposed or undispositioned waste materials at the site. So that goal of 400 cubic meters was something that we put together several years ago, the department at Savannah River, as a challenge to our contractor, and you know, not only a goal, but also a performance expectation, you know, with respect to fee and so forth, that challenges them to stay on top of accumulated waste so that it's dispositioned appropriately without building up a new legacy that then some future generation is going to have to deal with, like we have done in the past 10 years at the site. So that's where it came from. It was locally determined. The 400 cubic meters seemed to be a reasonable amount for accumulation during a year, and we just didn't want to exceed that because we didn't want to develop a new legacy volume of waste that some future generation had to figure out.
Well, okay, that's a great challenge goal, but isn't mixed waste supposed to be shipped off for disposal within 1 year by regulation?
The 400 cubic meter, I think, mostly applied to low-level waste, not mixed low-level waste. It's within that volume, but it's not unique. The 400 cubic meters doesn't just pertain to mixed low-level waste.
Oh. So this is not a regulatory limit imposed on you by DHEC? No. Okay, thank you.
Okay. So there's a number of cards that have gone up and stayed up. I just want to make sure that I have an accurate count of who's still here. Dave Vavakis, do you still have questions? Jim Lyon, do you still have questions?
Thank you.
Dave does.
David?
Dave Vavakis, CAP. Zach, I can only see targets for FY17. I'm assuming these performance measures have been in place for maybe a few years now, fiscal years now. It looks like if I do a quick count, maybe you missed 5 targets in FY17. How did you do historically, FY16, 15, 14? How'd you do against your targets in those fiscal years?
Yeah, so kind of going off memory here, last year, if I recall, like we've done pretty, you know, historically we've done pretty well. So kind of what Mike McLennis was talking about, like every year, like you know, you set a bar and you meet that bar and you're pushed to kind of keep escalating that bar, and you know, eventually you get to a point where you know you may or may not make it. I want to say historically we've done pretty well. And for the challenges or the targets we haven't met or have been far off, you know, 1 or 2, you know, hey, like we were right in that ballpark. There's been I want to say a good reason why we didn't meet those. Kind of like this year with the melter. You know, I consider that a pretty good reason why we weren't able to meet the vitrification in the solid waste.
How would you categorize the performance in FY17? Is it poor or is it average or?
Well, you know, I won't say poor or average. I mean, again, every year is unique. You got to look at it in the total. Mike McLennis kind of like really like when you look at the life cycle of something, like say for the melter, it might have been planned a couple years ago or a couple years from now. When you look at the end state, like over the life cycle of a program, you know, 1 year is not necessarily going to set you back. So you know, you can kind of look in 1 year snapshots, and you might be inclined to think, oh, we missed 7 targets or 5 targets, and oh, that's a poor job. But it might not necessarily be the case. It's again, we get pretty aggressive with these targets because we hit these targets, and again, there's just always this constant pressure to like, okay, let's do better. Let's do better. There's that natural thing to like set bigger and more lofty goals. So I wouldn't say poor. I mean, it's.
Let me comment on that. This is Terry Spears. I'm looking at the same metrics that you folks are, and I know we're talking about it in terms of characterizing performance. I would say our performance this year has been good, with the exception of the liquid waste program, in which we failed to meet our targets for a predetermined reason. In other words, we had an outage that was unanticipated when we set the targets, and then we weren't able then to keep up the pace necessary to meet the targets. So we did miss those targets. However, with respect to the other targets, our performance was good. We either met or exceeded our targets for all the other cases: nuclear materials, solid waste, transuranic waste, all those we met or exceeded. The soil and groundwater program met or exceeded. So I think the performance has been good. What I would like to be able to do, as an executive managing the program at the site, is to be able to set more aggressive targets with some assurance that the funding would support our meeting those, and particularly in the liquid waste program. So we set, for example, 100 canisters this year, I believe, and that's largely paced by funding. So, we anticipated at the beginning of the fiscal year, or before that, as we established these targets, that would, be what the facilities would be capable of achieving given the funding levels that were established for, or we anticipated for the program or had actually received. And so we set those, and then we failed to meet them. So I think what I'd like to see is us be able to set more aggressive targets with some assurance of funding that would allow us then to confidently proceed and hopefully meet those targets. Reminder, in the past, not too distant past, we've been able to produce about 300 canisters through DWPF in a single year. It has that capability. I'd like to see us establish a goal like that every year. It's not reasonable for us to do that unless we have the funding to support it, though. So I just want to kind of characterize my view on the performance this year. I thought it was good, with the exception of liquid waste. And the problem with liquid waste programs, I'd like to see us set more demanding performance expectations going forward.
Oh, go ahead.
Maxine Maxted, DOE. I just want to make a clarification on the spent fuel one, because you're looking at it in a different view than what you are the others. We actually came in under our inventory, and we came in under our receipts, so that's a good thing. So that's not that we missed those targets, we came in under, and it was all due to one reactor that had a transporter issue. So when you're looking at the spent fuel ones, you don't want to exceed those targets, you want to actually come under those. So it's a different way of looking at the measures from everybody else. Thank you.
Bob, go ahead.
Bob Dorcab. I, for one, want to thank DOE for continuing to keep these performance metrics and being transparent about it. It provokes a lot of questions from the cab, and I think they're good questions, and I think you got a good story to tell. I was just as far as presentation, some of the questions, well, we had good years, we didn't have other years that were so good, can we catch up and so forth. I was just thinking in terms of presentation, that you could do something either pro forma or with graphical presentation of multi-year performance in terms of these metrics, in other words, yeah, like a trend analysis, or what happened 3 years ago. You see things ebb and flow, and then that tells a story as well. Because you can't. It's not an even from year to year, obviously.
Dan, you ready?
I'm ready.
All right.
Yeah, Bob, thank you for that segue. Perfect. Dan Kaminsky, Cab. With that, I did have some questions out of the gate from the chairs meeting. We had a recommendation from the chairs that had to do with a dashboard, correct?
Yes.
No, from the chairs meeting, from the national.
I didn't hear anything about any recommendation.
Earlier one from May?
Yes.
From the spring. Because they had alluded to some of what we're talking about today with regards to KPIs, dashboards, and reporting. So I was looking for a more streamlined, I think, consistent format. I couldn't find it on our site this last month, so.
I think it only gets put on the site
So,
if it's approved, and I don't remember if that one.
so here's the status of that one. We did, Mike McLean's DOE. When we last voted, if you recall, what you're remembering is from not the last chairs meeting, but the one before that, the chairs came back with the recommendation that EM1 challenged, let's go look at, we'd like to be thinking about complex-wide things like that. It then went back to the full chairs meeting, but has not been presented and moving up further through the system. So it was discussed at the last meeting, but it hasn't been enacted yet.
Okay.
So it's still being worked through the cab chair system, if you will. Just like it takes a couple rounds of meetings for you all to work your recommendations at the chairs level, it does, and they only get together once or twice a year.
Okay, so I prematurely stole my recommendation for KPIs. and dashboard. So my apologies for not pursuing that, thinking that was going to happen, and may have made mine a total moot point. So with that being said, I've got a few questions, and that's why I asked to be last. I was hoping some of them would be answered by other members. So first off, I appreciate the very much transparency that DOE and SRS try to provide the cab and the public in general. And I know as a cab member, the additional knowledge and education that we have helps us make sense of some of these metrics better than I think the average citizen looking in would see them. And that kind of brings up a few concerns. So we see the annual results today, and I'm just questioning, how well did these track throughout the year? Were these red, yellow, green? Was the trend in a positive direction, or did folks have to hit home runs at the end of the year to make them happen?
So, you know, most of these, you know, speaking from, I'll say just about all of them, if not all of them, are tracked fairly well. Like, there's a very good indication exactly how many canisters that are produced year to date, and where do we think that we're going to be towards the end of the year. There's not necessarily, there's always ebbs and flows. We kind of talked about, I think it was last committee meeting, like maybe the effects on like budget and stuff. Like, so maybe like a continuous resolution, kind of like maybe a slow start, and it kind of picks up pace towards the end of the year, towards the end of the fiscal year. I think that's kind of a natural thing. You know, to be conclusive, I don't know. There may be someone that like nailed, like they were able to pick up production the last quarter and hit some of these targets, but you know, absolutely, I don't know.
Hi, this is Thomas Johnson, DOE. Not only you're looking at the, I guess the higher level targets that are set with headquarters, but we have the performance evaluation and measurement plan. This is what the fee to the contractor is based on, and so for each of these, there's also something in the, what we commonly refer to as the PIMPs, and we have interaction with the contractor on a monthly basis to talk about their performance. So when we ran into things like needing to go into the outage, you know, we would look at the PIMP, and then we would also make evaluation as to where or what kind of adjustments we needed to make on the contractor's performance to ensure that they, even though they couldn't get to some of these targets throughout the course of the year, in the case of like DWPF being shut down, we set revised targets for them on other scope to make sure that they were working on the right kinds of things, and we would have the normal interaction with them on a monthly basis.
Okay. So that also leads into, if you want to pull up the liquid waste tank closure slide. So the progress basically down there is fairly dismal from this slide. Would we not agree, at least from what this slide says? Though I highly doubt that you guys have been sitting on your hands with regards to tank closures, because you have a slew of other activities that you're in progress of performing.
So I don't think you can say that. You got to look at how, again, how this metric is.
I'm only bringing this up because we see the year-end results, and it's such at a high level aggregate that the average public citizen looking at these figures is going to say we've got nothing accomplished. So is there a better metrics to show us that shows us more progress than 0 tanks closed?
We could probably look at, like, you know, estimation to complete of like our current tank closures, but I know historically, like, you know, folks, they care about the number of tanks closed. So this is kind of a holdover for several years. If that's something that we need to adjust, I mean, we can.
This is Thomas Johnson again. So Dan, like I said, these were the high-level metrics.
Absolutely.
But we also have other things like, before you can get to tank closures, we've got bulk waste removal efforts, and so we're tracking those kinds of things as well, but you don't see it in these metrics.
Right, but that's also been kind of some of the questions from the board is we'd like to see those metrics more frequently. We get updates, but it's in a very verbal format where we have no trend analysis, we have no curve, we have no historical data to say, are we or are we not impressed with your performance since our last CAB meeting? And to heighten that, and that's the premise of the recommendation that I've stalled out on because I thought another one was in the works. And that's kind of where that's going, is that we have a better visual indication that if I'm targeting to put out 100 glass canisters this year, where am I today? Where am I expected to be next month? How many did you get done last year? Because from the public view, your budget remains flat and your performance is all over the map. And I know that there's extenuating circumstances because we get the inside story here. Mm-hmm. The average public does not.
Okay. I mean, we can, like I said, we have the higher level ones here. We can perhaps show or at least provide updates on the lower level or the supporting metrics.
It's not that you don't update us, it's the format in which we get the verbal update. We would be forced to put it into a spreadsheet, put it into context, and understand whether the trend is what we believe is positive or if in fact there's something we should be concerned with. And I don't honestly, myself personally, I don't believe there's a concern. I just believe that showing that trend analysis and having that data in front of us with a very predictive format would be much more beneficial to communicate to us.
So Mike McElhaney, DOE, Dan, I think what you said is fair, and we can put that in the work plan for next year to create to craft a presentation along those lines, maybe for the high-level waste committee to go pilot and try and pull that to get information together in the context you described. I think your points are fairly well made.
Well, just so you know, it's not a one-time presentation I'm looking for.
I understand, but first let's craft the vehicle for communicating the information, and we'll see what kind of value that can be for the department in tracking our own progress. But at least having an item in a work plan to go look at the historical performance is the first step, but down the road I think you're trying to highlight for us.
Okay. And then just one other question or concern maybe, or a comment, depending how you look at it. On slide 15 with the soil, water, and facilities, the D-area ash project, we've equated at a high level number of sites. Now, obviously, there's a huge disparity in Site A versus Site B versus Site C, and you've done 408 to date. Do we have an idea as to, have we done 408 of little tiny sites, or the biggest ones?
Mike McElhaney, DOE. I'll give you the overall perspective of the D-Ash project. It gives you the percentages complete, I think, up there, but we're quite a ways along. We're running about 5 to 6 months ahead of schedule and several millions of dollars under the total project cost estimate. And you're right, the different areas are the little mountain of ash. I think that was 1D versus the cleaning out of the retention basin, which is 2D, versus the 1D part where we're currently fishing out all the trees and digging out the ash and mounding it on the eastern side, I believe, of the cell. All that each area there is not created equally in terms of level of effort or dollars.
And just kind of reiterating one thing we had touched upon with regards to the budget and the perception. The PBS levels haven't changed significantly since I've been on the board. So, but the performance is kind of up and down all over the map. And that was my major concern when you look at slide 10 on the liquid waste. I mean, it's showing no activity. And I know that's not true. But what message are we sending? If I give you $100 billion, you're going to do nothing. If I give you $100 billion, you're going to do something. And then the next year I give you $100 billion and you do nothing. So it's, what are we doing? I mean, I don't see the correlation with these metrics to show where the money went. And obviously they didn't give you $100 billion just for this particular piece.
This is Terry Spears with DOE. Let me comment. I think you're raising good points, and I think what you're pointing to also somewhat is the complexity of conveying the progress that we make in a very complex environment like we operate in at the site. You know, one of the things, the funding levels for a PBS doesn't necessarily show how that funding has to be allocated. In other words, it doesn't show things like growth and pension, you know, legacy medical benefits. It doesn't show the necessarily the share that has to go towards hotel costs. In other words, the cost of maintaining aging infrastructure and so forth. So it's very hard to convey that and also put in perspective how that relates to what you're able to achieve. That's kind of what I was relating to earlier with respect to setting the goals. You know, you have to depend on the funding level to, you know, be able to set realistic goals and then work towards achieving them. So it is a very complex environment, and as Michael said, it's something we're willing to, you know, take on in terms of trying to figure out how to more effectively, you know, convey performance in that kind of an environment going forward. These metrics are very high level, and some of them, again, just like tank closure in today's current world, you know, there were none scheduled, so we actually got none done. That's really not very informative, but nevertheless, it's a metric that we've managed to. What I think would be miraculous is if we could show we closed 3 even though there were none scheduled. But we're working towards that. It's very complicated. Thank you for the comments.
And actually, the biggest thing that I did enjoy about these slides, by the way, is you had the end state, and that's kind of what the data trend would help show. How are we going to achieve that end state? Is it in 5 years, 10 years, 50 years, or not in anyone's lifetime in this room? That's the stuff that's important to the public. And I believe that being a little more trend analysis and having those types of graphs and showing the progress, I think, number one, it does start correlating what you can get done with the money you're provided. And I think it gives you much further ammunition to go and ask for more. And I think we're all interested in that. We have an ad hoc committee to try to get you more, just to get you out of that whole crisis with the pensions. But that being said, we're on your side on this, and I think everyone on this cab has been on your side. I've never seen anyone being vindictive, anti-DOE, as much as we want you to do the right things, we want you to get the right amount of money, and if we can help you do that, I think we're all ready to go to bat for you.
Thank you, Dan. It seems like your questions raise some more questions. So let's close it out with the last 3 here. We'll start with Joyce and work our way down.
Joyce, Underwood, Cab. A lot of people have said a lot of things, and I want to try and connect the dots to clarify what I have heard. The interested parties have no interest in trying to play catch up because of the outage, because A, the budget, and B, we would have had an outage anyway. Is that correct?
Mike Michelanis, DOE, except probably for the part that the interested parties have no interest. I mean, there is a lot of interest in trying to catch up the schedule if possible. The contractor, SRR, actually took on a pretty aggressive schedule for an outage that wasn't completely unplanned. I mean, we knew that the failure was coming up, but they still took some pretty aggressive targets to do this. So there is a lot of interest in trying to catch that up, but everything else you said is correct. We just basically pulled that window up forward a couple years in the schedule.
And let me also, this is Terry Spears, just to add to what Michael said, in that it's not altogether apparent, but the outage that we took in liquid waste this year, even though it's a hit now, we expect it'll pay dividends later because it'll allow us then to operate the SWPF, which produces a higher volume. So this gives us an opportunity to get ready for that, which, as Michael said, is in the interest of kind of catching up in terms of disposition of waste on the site. So it's an investment, the way we look at it, to do the outage now rather than wait till next year when it was actually envisioned in the system plan for liquid waste, I believe. So we didn't have to affect the production of SWPF at the time. We're doing it kind of early, and hopefully that'll pay off for us.
So to follow up with that, will this or will this not result in a significantly more aggressive goal setting in the next fiscal year, or next several fiscal years?
So Mike Michelanis, DOE, yes, but let me explain what I mean by that. This year we had a goal of, I think it said 130 or so canisters, for example. Next year would have been a low one because that's when the outage was scheduled. So next year it'd be much more aggressive because maybe the target would have been 50. So it'd be more like 134. So from that perspective, yes, it would be more aggressive. Would it be more aggressive than the 134 or so that was set for a full production year the way we're funded now? No, we'll probably, because we're basically going to be catching up where we are next year. That makes sense?
Yes, that makes sense. Thank you so much.
And we're tag teaming this, so let me add to that, Terry Spears.
Sorry.
So the other dimension to that, or at least one of the other dimensions, getting back to the complexity of what we do, is what funding are we going to get from Congress to be able to achieve this production that we're talking about? So that'll have to be factored in, and with a lot of what's our pension contribution going to be next year? So I mean, those kind of things have to be considered. So we're not, sitting here today saying, oh yeah, look for high numbers. If we can, we will, because we'd like to make progress. That's what we're all about. But we got to take reality into consideration as we do this, and it's not a simple environment.
Doug Howard Cap. Savannah River's performance, is it in any way compared with the performance of other sites such as Hanover and some of the other sites out there? Or is the mission so different?
You mean
there's no comparison as far as performance-wise?
So there's similarities to our sister site, Hanford. They have a liquid waste program. We have a liquid waste program, but there's a pretty big divergence. Each issue has its own unique circumstances and its complexities. You layer in infrastructure issues that are different to the site. It's tough to get you could benchmark other sites, but I don't know how fair of a comparison that is. Because it's pretty complex.
So if I could contribute again, tag teaming, one of the reasons I've stayed at Savannah Riverside for over 26 years is the fact that we make progress at Savannah Riverside. No other site has dispositioned any high-level waste canisters. No other site has dispositioned any spent nuclear fuel. Other sites are making progress in terms of D&D and soil and groundwater cleanup and that sort of thing, and I'm not diminishing that. I'm just saying that with respect to the missions that we have here, not too many of the other sites can claim the kind of progress we claim. Even though our numbers are low this year, and I readily admit that, or they're evident, we're presenting them today. But we do have the capability, and we do make progress here in those very tough mission areas, and that's unique in the DOE complex. I'd like to take credit for that as well.
Thank you.
So I'm going to take issue with Dan just a little bit. Come on. So I used to be the head planner for building a nuclear plant right when all the nuclear plants were failing, and our bosses said, you're not going to fail. So we need more data. We need to understand the data. We need to understand the trending. So we loaded them up. They came back and threw it back on our desk and said, this is unreadable. We can't read this. This is too much data. Can you make this higher level? So getting that balance so that it's meaningful and we can understand it, we as the CAB, is a pretty hard balance to reach. I just wanted to point that out, that it'll be a great thing if we can get it, but it's going to be not too easy.
Tom, I agree with you 100%. We're at the other end of the spectrum right now, so let's bring it in somewhere center.
Any other questions, comments? No? Thank you, Zach. Yep. All right, so we're just about on time. Let's go ahead and move into public comment. We have one signed up, Tom Clements.
Thanks, James. And to the CAB, thank you for your service. My name is Tom Clements, and I'm the director of Savannah Riverside Watch and also currently a senior advisor to the international environmental organization Friends of the Earth. And I've been tracking, hard to believe this, Savannah Riverside issues for almost 40 years, off and on. So I want to make three main comments. But first, Savannah Riverside is part of a alliance of grassroots groups working around the Department of Energy sites called the Alliance for Nuclear Accountability, and particularly in California, Washington State, New Mexico, and Idaho, we have a strong relationship with congressional delegations, and though DOE does a poor job of stakeholder outreach, we're always willing to fight for cleanup funds for Savannah Riverside and the other DOE sites. So the three things I want to discuss. First, your you're probably familiar or becoming familiar with the oversight role of the Defense Nuclear Facility Safety Board, which provides congressionally mandated oversight of DOE facilities. Its strategic goals, and I just took this from their website, include improved safety of operations, strengthen safety standards, strengthen safety in design, and achieve excellence in management and communication with stakeholders. Now, despite the valuable role it plays, and I've had many years of experience with the Safety Board and try to meet with them at least annually in Washington, the Defense Nuclear Facility Safety Board is under attack, including by the board's own chair, Sean Sullivan, as he put in writing in a June 29th letter, which I have a copy here, to the Office of Management and Budget. He basically recommended either eliminating or downsizing the agency and made the claim, false claim, that its mission was a relic of the Cold War era defense establishment. And we just heard of everything that's still going on right now. This is not a Cold War relic. On November 13th, the chair of the Energy Communities Alliance, Chuck Smith, of the Aiken County Council, wrote to Mr. Sullivan in defense of the Safety Board, kudos to him, and said it was a key independent organization that focuses on nuclear safety and that it should be retained. So I request to you that you become informed about the role of the Safety Board. I know you've discussed having them present in the past, and that might not be their role, and that you communicate to Savannah Riverside that the board plays an important role in SRS safety matters, thank you, especially regarding critical things such as the H Canyon exhaust tunnel. And I printed out the last weekly Safety Board reports, which are online from October 6th, and in fact it does get into the H Canyon exhaust tunnel, which is a key issue now before Savannah Riverside and the Safety Board itself. Second, as you may have seen, the House and Senate Armed Services Committee agreed to the conference report, and I've got a copy of it here, key pages, for the National Defense Authorization Act for fiscal year 2018. That report is spelled out in a news release that Savannah Riverside Watch issued on November 10th, and it's posted online at srswatch.org, specifies how the Secretary of Energy can waive requirements to continue construction of the $17 billion plutonium MOX fuel plant and pursue an alternative option for disposal of plutonium and its removal from SRS. Given the massive cost overruns, lengthy schedule delays, and continuing construction and design problems with the MOX plant, it's clear that DOE is inching away from MOX and toward a plan to dispose of plutonium as nuclear waste via the dilute and dispose method, which would take it to WIP. Now, I have some problems with this method, but that's where things are going. Because this is going to fall more and more in your lap as DOE finally comes up with a plan to expand plutonium disposition via dilute and dispose. I request that the CAB stay abreast of those plans and that you request frequent updates on this during 2018. It should be in part of your work plan. I'm not exactly sure how that's going to be for 2018. You'll recall in the metrics that only 75 containers were downblended in fiscal year 2017, only 3% of the overall amount of 6 metric tons. So I think over the next years, as MOX continues to go down, that you'll see an increase in that. And just commenting on MOX, I hear nightmare stories on a weekly basis coming out of the MOX facility. I've told you that many times before. It's still continuing. They're not able to close the work packages because of design and construction problems, and I think that's finally going to catch up. So finally, and thirdly, there is some good news concerning the proposal to transport highly radioactive spent fuel from Germany to Savannah Riverside for processing and dumping. While it has become clear that those backing the scheme are eyeing millions of dollars in transporting and processing the irradiated graphite fuel balls, the situation in Germany continues to dictate what will happen with this material. On November 10th, the German Environment Minister, Barbara Hendricks, visited the Jülich Research Center, where a large part of this material that some want to bring here is stored. She met with a local elected official and local citizens who presented a statement from Savannah Riverside Watch requesting that the project be terminated. She confirmed 2 key things. One, the AVR, that's the name of the reactor, spent fuel at the Ulick site is going to be transported, as I've relayed to you many times over the last 3 or 4 years, to a storage facility at the Ahaus site in the same German state. And that due to the German law passed in the middle of 2016, I've related this to you as well in the past, that the spent fuel in question cannot be exported. There are already 2 lawsuits in process, and some people don't seem to realize that when this comes to a head that there will be court cases to stop the export. I posted the link to the TV news coverage, which is in German, on the Savannah Riverside Watch website and on the Facebook page. Your recommendation of September 26th not to export this material has had some impact in Germany, and Ms. Hendricks also understands that DOE has not performed a nuclear non-proliferation risk assessment of the reprocessing technique that's being developed or was being developed by Savannah River Nuclear Lab, and I understand she's concerned about that. So I continue to monitor this matter and get regular updates on it, and that you continue to work to stop Savannah River site from being any kind of international nuclear waste dump. I want to thank you for your service, all your questions. I think everything that you're raising with DOE in response to the presentations is very helpful to me as a member of the public, so I want to thank you for that, and I'm always available if you have any further questions about the role we're performing. Thank you very much.
Okay, that's everybody who had signed up for public comment. We do have a few minutes left. Rose?
I'm Rose Hayes, member of the public, former CAB member, chair of the Nuclear Materials Committee. I wanted to reiterate what Mr. Clements has just said about the Defense Nuclear Facility Safety Board. Some years back, I can't remember exactly when, but it was a lot of years back, the board issued a citation to the site about the loose materials that had been discovered in the 235F facility. I reviewed the site and I appeared before the board, and I recall that some of the workers told me that they were just simply pulled away and assigned to another campaign at a point in maybe '89. And that material had just sat there, ignored in all those years. Without the investigation and citation of the board, it might still be sitting there today. And what the conclusion was at that point, and I don't know if that originated from the citation or from SRS's follow-up investigation, but the conclusion was that if there had been an epidemic of some sort, an event that was disastrous like a full facility fire, that 1,000 workers would have been immediately exposed fatally, and others lesser so as you moved away. And at that time, we were also assured that whatever had happened in the worst case scenario, it would never have moved off site. I see now that the current assessment is it could move off site. So I guess I'm urging you to do 2 things. First of all, I'd like to know how we're recounting what could happen in the event of a disaster at 235F. How is it being recounted now that we assume it could move off-site? And what are the numbers there? How many people? How far? And secondly, I'd like to urge you to advise DOE to support the safety board. There is no other analogy to the safety board insofar as the nuclear complex sites. And they do a good job. They do a job that is critical. And I hope that you will support them. Thank you.
Okay. Thank you, Rose. Is there anyone else who wanted to make a public comment? All right. Seeing none. How about we go into voting today, huh? Chelsea's going to hand out the paper ballots and the clickers for your recommendation voting afterwards. As she's handing those out, feel free to go ahead and fill out your paper ballot. I'll come behind her in just a moment and pick up your paper ballots. I'll have you slide them into the envelope, okay? We'll give you a few minutes to vote. Afterwards, we'll finish up all the voting, and then we'll move into a short break, and that's when Delisa and Eleanor will count everything. Sound good? Any questions about the voting as we're going through? Just hang on to it for now.
Just one committee to go clean this out. What would make sense for us?
Well, we changed one of our internals to a mass sodium because the balance didn't mean it was
right. But it really would.
I believe your first question is the closure for recommendation 347. Do you need the recommendation for discussion? Okay. Curation facility. So Strategic and Legacy Management decided they wanted to close the curation facility recommendation, correct? Right. Okay. Do you have any further updates beyond, David, I think you covered it a little bit yesterday. Do you want to cover it again?
Give me a second.
Bob Dorcab, the committee, Strategic and Legacy Management Committee, reviewed that recommendation, and we got the response from DOE. That's what we reviewed, and we were prepared to close that recommendation after our discussion, but there were some issues that came up yesterday. Okay.
No, he just discussed it. There were no issues. He just wanted to discuss it, or discuss the response a little bit and see if you're ready. If you're ready to vote, we can pull up the vote and do it.
Yeah, I mean, it was a multi-part recommendation. DOE DOE accepted all of the subparts to that recommendation, and for that reason, the committee voted to recommend to the full board that it accept DOE's response and close the recommendation.
So do we have are these working?
Oh, yes.
To close? Okay.
So I move that the board close the recommendation on the curation facility, recommendation number 347.
Please hold your votes until the chair opens
Great.
it.
I guess we need a second for that
Second,
before
yes.
we start voting. Good, thank you. So all those in favor of voting to close the recommendation, please indicate yes or no. I know, I hate those.
Still got one more. Number 12. Look on the back of your clicker. Two more? Jim?
No, number 12.
Come on.
There we go. All right. Everybody's voted. Does anybody need to change their vote? Nope. You voted your conscience? Okay. We close the polling, please. Oh, hey, look. Everybody voted to close. All right. So 347 will now be listed officially as closed on the website. Any questions? Let's go to the next one. Do you want to know how many times we tested it yesterday? My missus was ill when I got home that late. All right, sir.
Question on, you guys tested the changing, so if someone hit yes by mistake or no by mistake?
Right. If you can change it as many times as you'd like up until the point when we close the polling.
As long as you test it, because we don't get to see that.
I promise. Okay.
Okay, so just want to make sure we're on time. So the second one, or the first recommendation that we're voting on today, is the Savannah River National Lab funding. Do we have a motion on this recommendation? National Lab funding.
State the motion.
I'm sorry? Oh, I didn't see it. Is there a second?
Second.
Okay. So all those in favor of this recommendation going forward on the National Lab funding, please indicate either yes or yay or nay. Or not.
Not desk glass waste storage. You gotta pull up National Lab.
Okay,
She
so
skipped ahead. Well, there we go. Okay, so if everyone will please cast your votes.
it's not working.
It's showing that it's done.
It's not lighting up.
Is it because you had to restart that one? All right, so close it out and restart it. So one more.
Who is it?
So
Who is
who's
it? Number
missing?
12?
There we go. Go ahead and close it out. So 88% vote in favor, 13% were no.
All right, well, it carries. Thank you. And the second
Close it out
one,
and go to the next.
which is different than it is. Which one are we doing next, Chelsea? The glass waste storage or defense waste processing? Yeah. Okay. All right, so the next one that we talked about yesterday is glass waste storage. Do we have a motion?
May I?
Oh, yes.
This is Narendra Malik. I think since there were a couple of comments on this yesterday, so I went home and made some corrections.
Okay.
They were in the second paragraph, which I thought it glassware storage. Oh, is this mine?
No, I think you had defense waste processing.
Oh yeah, I'm sorry.
It's okay. Do you want to go and would that be easier? Do you want to do yours now since you have your changes up?
Can we do them in order of the agenda?
Yeah.
Because we have to load these questions.
You're fine, so we'll go back to it, which is the glass waste storage. Do we have a motion on this recommendation?
I move to accept.
Okay, do we have a second?
I second it.
Okay. So all those in favor of moving forward with the glass waste storage, please indicate with your little clicker.
Wait, green color.
Why isn't it? There's all 24. Is everybody committed to their votes? All right. Close it out. And that one passes as well.
Good. And then the third one.
Hang on. I don't know who abstained, but abstentions have the right to comment.
Abstentions have the right to explain why they abstained if they wish.
Would anyone like to identify themselves as the abstainer and share why they wish to abstain?
Nope.
All
Okay.
right. And then the third one is Narander's, the Defense Waste Processing Facility, additional field equipment storage. I guess before we take a motion on this to move it forward, Narander, is there any discussion that you'd like to have?
I had a couple of comments yesterday. One Dan suggested for the second paragraph, there are a couple of typos which I have corrected it. And then in the fourth paragraph, it was verbatim, so it needed quotes, and I did that. And there was one comment from the public that I should give the references, so I have given the references in numbers. These are the only changes.
Great. Thank you. Does anyone else have any other comments or feedback? Hearing none, do we have a motion to, oh, I'm sorry.
Mary Weber Cab. I can't read the screen from where I'm sitting, and I just wanted to see what the final point of the recommendation was in terms of the timing, because I was unclear when we left it yesterday how that was going to be phrased.
Okay, so can we scroll down to recommendations?
If somebody could read the last part, I feel like I'm at the eye doctor, number 3.
Start the construction to keep the construction costs
I can't see
low,
from
and
here.
it should be completed as soon as possible so that it does not impact high-level waste disposition schedules.
Okay, thank you.
And Narinder, is that the wording that you wanted? Is that what everyone felt comfortable with?
I had agreed to that.
Okay. Good. Is there any other feedback on this recommendation?
Dave Vavagas Cab. I'm just wondering, what is the, once this is completed, what is the maintenance costs annually to, or if there are any, to, for this unit?
Can anyone fill in what maintenance costs would be on an annual basis?
Narendra Malik, I think based on my past experience at DWPF, it used to be a weekly inspection by the RADCON people and construction people to make sure there is no water leakage and everything is intact. Other than that, I don't remember anything else happening. It was sitting in the way out in the facility.
Okay.
And they check the crane there now and then. So these are the maintenances there.
Does that answer? Yes, maybe kind of well. Okay.
Good. Is there any other feedback? Okay, hearing and seeing none, do we have a motion to vote on this recommendation and approve it? Do we have a second? Earl is seconding. All right, so all those in favor, please indicate, or if you're not in favor, or if you're abstaining.
All right. Does everybody got their vote locked? You've decided? All right. We're going to close the polling. And 96%.
Great. Thank you so much. So all three of these recommendations will go forward. And I think with that, are we taking a break now while the...
Oh, in every possible way.
Oh, good. All right. So what time? 10 minutes from now? So 3:30?
You know, let's make it 3:45 just in case. Let's give them time to count it and recount it just to be sure.
And we still have 2 presentations left,
Yes,
right?
you do. Yep. But you still have plenty of time for it.
So you're giving us a half an hour break? Is that what I heard you say?
No, 3:25.
Go. There she is. All right. Well, we've had a few requests to go ahead and announce. Dawn, do you want to wait before? You left your phone? Should we wait for you? Because I'm going to go ahead and announce the results. Sorry, I'm having to count because they didn't. Okay. Is that everybody? Dawn, you're back. You ready? All right, everybody. I'd like you to congratulate your new chair, Gil Allensworth, and your new vice chair, Doug Howard. Congratulations, gentlemen. I know that you'll do everybody proud over the next 2 years of your term. Thank you. And I'm going to hand these back to you. I don't want anything to do with them. All right. So up next, we have your continuous improvement presentation from SRR and SRNS. We've got PK Hightower from SRNS. She's going to kick it off, and then Rodney Blackman from SRR. So PK, if you're ready, come on up, and we'll get started with your last presentation of the day. Y'all aren't excited about that? Get news, PK, you can stretch it out.
Thank you. And that's the timer. Okay. Good afternoon. My name is PK Hightower, and I'm the Continuous Improvement Manager for Savannah River Nuclear Solutions. And I appreciate the offer from the committee to come back and to give you an update on our program. Unfortunately, we are the last, and I know you guys are tired. I've been through this, and I know it's a lot of information to take in, so I'll try to be as brief but as direct as possible on the things that we've done in this past year and to give you some highlights. And if you have questions later, you can ask, but I'll also leave some business cards in case you want to contact me, or you can contact me through Zachary Todd with the DOE-SR. So we'll get started. Basically, we started our focused improvement transformation, which is basically, we call it FIT. That's a collaborative, closed loop, process focus and discipline approach to aid in. And one of our biggest things is raising employee engagement and satisfaction, reducing costs, increasing productive capacity, improving quality and timeliness of product and service, and also increasing, the most important thing, the value for our customers, and making sure they understand that we're serious about our stewardship of what they've entrusted with us, and that we show them the value in having us as the M&O contractor. In FY17, our productivity and efficiency savings was $42.9 million, which brings us up to, since the contract started, of $320 million of savings in productivity and efficiency savings. Some of those are reinvestable funds, and we'll talk a little bit more about those reinvestable funds. But our IDEAS program, which is the suggestion program, which we've had since the early 1950s, we've had about 1,100 of them submitted, which were the cost savings of $1.2 million, and we've implemented 237 of them. A lot of them deal with safety, cost efficiency, and other issues. If it's a cost efficiency issue, then we would note it here, which would be separate from that total right there, okay? So another important issue that we had this year was a performance-based incentive cost initiative, where the department asked us, incentivized us to go look for reinvestable funds. And why was that important for us to look for reinvestable funds? They wanted us to be able to look for funds that we could go and reinvest into not just brick and mortar infrastructure, but also our IT infrastructure. So with the limited dollars that we have, it's always a good thing to try to find money to go do an additional scope. And if you look on that list, that's a partial list of scope that we were able to bring forward and perform this year based on the fact that we've identified about 6.7 million. The challenge was for us to look for 5 million, but we identified about $6.7 million. And those are some of, that's not an all-inclusive list, but that's a list of some of the items that we additional work scope that we did in FY17. And now what I want to do is kind of highlight a couple of, I got 3 particular projects that we did this year. And one of the big things is for us, and excuse me for walking across that, is our L area spent fuel and being able to have that spent fuel basin, the transfer bay open to receive fuel if we need to in emergency situations or at the request of the department. So this value stream analysis looked at from the time a cast arrived in L area until that cast leaves L area. We did a value stream analysis and we had 4 improvement events and 9 projects and 7, excuse me, hit the wrong button, and 7 just do it. And basically what we looked at optimizing our preventive maintenance schedule so it wouldn't interfere with the shipments. We also looked at process and procedure improvements and tool improvements, just looking at basic things like absorbent rags. If you got something where you keep having to wipe when you're working in a basin with water, you know, that's going to slow you down. We looked at redesign of bundle inserts, all those types of things, trying to be more effective and trying to get that cast in and out as fast as possible. And why is that important? Well, if there's a situation where the department wants us to receive fuel, if you don't have an open transfer bay, then you can't receive the fuel. So that was important. So the impact was only about $623,000, but what made this very important for us was the employees were engaged in trying to ensure that they could get that cast in as fast as possible and out. But the concern was criticality rules. And so the team involved the criticality safety team as well to try to figure out how could we not have to, when it comes to looking at criticality, we had some issues with redundant rules. And there was times when we would go back and we'd realize they were doing the same thing at different times and it wasn't necessary. So we had the criticality team there and we were able to reduce some of those types of things. And that's where some of that savings came from, was the duplicate redundant criticality rules and the checks and things that was happening. We involved the right people. They had regular meetings. The facility had the personnel involved in looking at the metrics, looking at things on a daily basis. And so it was very important for us to engage the employees, because who knows better the process than the employees? And so to have them as a part of the team and working was a benefit for us. And they own this to the point where now we don't have to be there on a daily basis. They're improving on a daily basis themselves by tracking their metrics and looking for opportunities to improve. And then another process of sourcing and recruiting candidates. At this point, you know, we're at this point where we have a lot of people like me who have been at the site for 30 plus years, and then we not have those who are coming in. So we've got to be able to bring people in so that they can, and we call it knowledge capture, they can capture that knowledge from some of our more mature employees. And so it's important for us to get people on site and working in the field as soon as possible. So this project here looked at the time a business unit looked at a staffing plan and decided they needed someone until a requisition is pulled from the gateway, from our process to say, we're finished, the requisition's been filled. So it was important for us to look at how to reach and retain more of a targeted audience for filling our jobs. We know what the requirements are. We know what it takes to be a nuclear operator, a maintenance mechanic, a RADCON inspector. So we went looking for those people who had the basic knowledge. And then the team recognized the fact that we didn't have a system, we had a lack of process knowledge, no visible process for people to go and try to field erect. We had people going and doing things twice because they didn't understand that there was an existing process. So we got the right people in the room. They developed strategic staffing plan. They hold strategic sourcing meetings. They benchmark competitors' websites and systems to try to understand what could we do and how could we learn from that. And they develop a centralized location for process information. And now we have a system that's documented. The requirements are there, and everybody understands it. And that impact was about $1.9 million. And this is the K Area 9975 shipping package life extension. We have a very detailed program for our 9975s, which are shipping containers that contain the 3013s inside of them. And then inside the 3013s is this material that they use that's bound for MOX. So what we wanted to do was to extend the life of that shipping container, which is not being used for shipping, but for storage. There's a detailed program, a detailed surveillance program involved with that. And so we used that detailed surveillance program to ensure that we could extend the life from 15 years to 20 years. There were new safety calculations based on the information from the surveillance program. And so that surveillance program and the SRNL testing provided that justification to extend it by 5 years. That extension, and if you didn't extend it, you would have to take and repackage each one of the 3013s into a new 9975. That would require exposure for personnel, the protective equipment, and time. And based on that, that impact is about $5.2 million. And so this program, this surveillance program, is still in play, but we're able to take that data as well as some SRNL testing and basically validate our conclusion that the extension is valid, we can technically justify it, and we can use it for future life extension activities if that should happen, if we should need that, if that material is not processed within the next 5 years. So those are just a few of the projects that we have available. And I'm going to let Rodney come up, and if you have questions, we're going to have some time at the end for questions. Thank you for your time.
All right, well, I'm Rodney Blackman. I'm the Project System and Execution Strategy Manager for SRR. Part of my responsibilities includes our continuous improvement efforts. And so what I'll be doing is giving you a little bit of a background, maybe a little bit of a backward look, then talk to you about what we're doing currently, and then what we've got right immediately in front of us. Obviously, our contract's winding up as a company, and so we're pushing hard to do a good job to finish well and finish strong. Our liquid waste mission is a continuous process improvement opportunity that's boundless. The whole mission is coming off of the liquid waste tanks. Obviously those tanks are very old. There's a lot of maintenance and upkeep that go along with that side of the business, all the way to brand new facilities that are just now getting ready to come online. So we've got 50 to 60 years worth of a range of equipment that comes together to form the liquid waste program, and I'm sure you've seen that in other presentations. Right now we have 43 tanks that are in an active state, and part of that input to our process. And we have 3 major value streams in terms of products that come off of this. And the first one is the fact that once we process waste out of a tank, we can then close those tanks. That's providing value in terms of protecting the environment and so forth. And we've been able to do that with 8 of the tanks that are out there fully grouted, and then of course a whole series that are in steps toward closure. The second value stream for us is our sludge waste, that is the high-level waste that comes down through DWPF, ultimately winds up in our glass canisters. And that process, of course, has been working for a number of years, and we've done things over the years to help improve the throughput and reduce the cost of that operation. But the main part of our liquid waste mission that's out in front of us now, of course, is salt waste processing. That's our third value stream. And it is the critical path to completing the liquid waste mission. So we've had ARP and MCU in operation almost 10 years now, and they are still what's working today. We look forward to SWPF coming online in the next year or so and really providing the horsepower, if you will, to drive this mission to completion. And I believe you've heard about Ticker, one of our new applications available coming online, or we're working to bring that online now. So those are our three value streams. From a product standpoint, if we think about our continuous improvement effort, we focus on the products. There's many systems that support this, whether it be administrative systems, engineering, those kinds of things, and we bring the same thought process in terms of continuous improvement to those efforts as well. Our lean business system that we've installed starts at the top with the overall strategic goals. On an annual basis, we update that with the department as in terms of looking at the funding that's available, the priority of the projects that we're pursuing, as well as normal operation of the facilities. So you've got the normal operations, you've got the ongoing maintenance and upkeep of the existing facilities, and then we're driving projects to that generally focus on throughput and reliability of the overall system. So at the very top, we get our strategic plan and develop that, and then that flows down through our value streams, the analysis we just talked about in terms of product, but also functional areas. We'll do value streams in those functional areas to drive down costs and increase efficiencies. Those lead us to improvement activities. This is where we really expand out, get a lot of our employees involved with the implementation of those improvements. And then finally, we are developing this at the bottom level, the managing for daily improvement. And this is an effort that we're really focused on at the present time, because this is where everyone gets involved. Every team member begins to understand where they fit in the overall process and how their actions impact all of those who are working around them. So the next three slides, I'm going to go over some of the aspects of the physical products and some improvements that have been made in the past, ones that we're working on now, and then we'll look at the overall results for the program. A good while back, or a number of years back, we put bubblers in the DWPF melter, and that, of course, increased our throughput through that melter. That would have been a bottleneck for us in terms of our sludge processing. Over on the glass waste storage building, identified the idea that we could double stack the canisters in the glass waste storage building, push off the need for an additional glass waste storage building. And I'm going to use the glass waste process. There's other options that are out there that may be considered, but certainly it doubled the size of the capacity by being able to double stack. And that's a process that's underway, actively working now. Over on tank closure, we were able to bring the tank closure team together. The upper left-hand side here describes the major steps for closing the tank. Before we applied the continuous improvement methodology, we were driving at 8 to 10 years to close a tank. We've been able to drive that duration down roughly in half, 4 to 6 years now. And then we're saving about 25% on the overall cost to close a particular tank. Now, I'll talk to you a moment about the saltstone disposal units, the SDUs. SDU 6 is now complete, not yet in operation, but expected to come into operation during FY18. Each one of these SDUs that you see up here are 32 million gallons. That was one of the improvements that our process brought to bear, was to get to the large units. They bring an efficiency in their construction costs, so there's a lot of savings across all of the SDUs necessary in terms of placing the low-level grout. So 6 is built, 7 is now underway. We've got site clearing going on there, and that process for bringing up SDU 7 is underway. As I mentioned, each of these are 32 million gallons. The perspective of the photo may make them look a little differently in size, but we wanted to show you exactly where the future SDUs are planned to be located, and this slide does that for you. So that's looking at our primarily at our product focus lines. Now I'll talk a little bit about the overall results, and we're measuring, and these are obviously forecasted savings. They're not necessarily everything that we've got in the bank, but when you look at the overall liquid waste mission, driving it to completion, and you're spending in the $400 to $500 million a year, every year you trim off the back end, you're saving approximately $500 million. So we've been able, thus far with the efforts we've done, to trim about $1.9 billion. If you were here last year, that was about the same value that we had last year. We've done a lot this year relative to focused on our outages, which I'll talk about in just a moment. And then these are the results of the overall program since we've had it in place. So I'll bring you over here to the right-hand side. We've done 132 events. When we talk about an event, we're talking about bringing a team together to solve a particular problem. And in those events, we've had the value streams that we've talked about, the 3 that we've talked about, plus a number of supporting value streams. So we've done 16 of those different value streams in the 4 years that we've been on this journey. Up at this point, up to 38% of our workforce has actually been through one of those events. This is a metric that's important as the program begins to mature. You want to get this up about the 60 or 70, 80% range of employees who are engaged in this kind of a process to really get to a fully mature program. The one number over here on the right-hand side I really want to focus in on, though, is the 68. That 68 number that's the number of events in which we had Department of Energy and or stakeholders involved. And so when you bring in DHEC, for example, and they bring their engineers into the room and they help us work through a problem and begin to see some alternatives that maybe an engineer working on their own doesn't know how to deal with that permitting process. But you have that permitting engineer who works for DHEC in the room with them. It's pretty special what they're able to do in those events. We've talked about the SDU 6 over here on the lower left-hand side. Above that is the salt batch qualification time. This is a relatively recent improvement that we've made. We've driven that batch qualification time down by 2/3, which equates to about 24 months off the overall life cycle of the liquid waste mission, and that drives us then to approximately $1 billion in life cycle savings there. Just some other examples here. In the center at the top is the procedures, error proofing. We have thousands of procedures. Being able to sit down with the right team and work through and simplify those procedures. We've got an ongoing effort to do that. That's relatively low-hanging fruit, and it's one of those things we can keep a small group working on for a long period of time. And right now we're seeing about 1/3 of the overall pages has dropped, 45% of the steps are dropped, and then about 48 or 50% or so of the actual sign-offs are dropped, making the operation of those procedures much more efficient. And then I'll just bring you over here to the bottom right-hand side where the tank closure part is. Been able to cut that schedule approximately in half and save about 1/4 of the cost of closing out tanks. Here's what we're up to today. Obviously, I'm sure you've had conversations. Yeah, make sure you can read this from the back. It's not intended for you to read it. If you read it and something jumps out at you, I'm sure you'll ask me a question about it. But what I really wanted you to see was this is our outage planning process. So we're in a major outage right now. We've got the melter 3 going into place. We've got repairs on the 3H evaporator and a lot of other PMs and being caught up and that kind of effort. The DSA effort, reworking those is very complex. This is a complex business that we're in. And every week our team meets together with a cartoon like this where we actually do go line by line through it and understand, are we getting the work done? Do we have the resources that are necessary in order to to keep the work going? And do we have the right priorities on this work? So we do this every week. This is really where a lot of our focus has been this year. And so our continuous process improvement has taken a little bit of a step back in order to support this ongoing outage effort. I will point this item out to you. We talked about salt batch and being able to reduce the overall time for validation and so forth. And in the center column there, that's a list of the analytes that we were analyzing as a part of that process. And in doing that, there were 125 analytes. We've been able to, by engineering and analysis, drop that down to about 25 that we really need in order to move a batch forward. And so the team did a lot of work to be able to get down to really what do we need to know in order to qualify a batch. And then these are some other notes and things from that particular effort. So just as I wrap up here, looking back over the 8 years of our contract, we've really been on our lean journey about half of that time. There's a lot of things that we can take pride in that we've done in terms of the number of canisters produced, overall what we've been able to do throughout the processing effort itself, both on the sludge side and the salt side. Challenge out in front of us, of course, is salt, and we're looking forward, and our team is really engaging with SWPF integration and what it's going to mean to be able to both feed that facility and then take the product from it as well. With that, I'll turn it over.
Thank you very much. I'm going to ask, because we have two different corporate entities here, that when you do ask a question, please let them know if it's for SRS, if it's for SRR, if it's for a combination question. So with that, do we have any cards going up? Dawn, you were first.
Dawn Gillis Cab, SRNS. On the K area, 3013s, or 9975, whichever one you want to. When you say the 5.2 million, is that deferred by this 5 years? Because you're still going to have to do that repackaging in 5 years unless you redo this process and says it can go another 5 years.
Exactly. The surveillance program, you're exactly right. That is the cost that we save by not having to repackage.
Right, at 15 years.
At 15 years.
Mm-hmm.
So in 5 more years, if we have enough data to technically justify it, then
Mm-hmm.
we can ask for additional time. But if not, then yes, we'll have to go back and read it.
So if you could go an additional 15 years, then you really would be fully saving this $5 million. But right now, you're deferring that.
Right.
Okay.
Okay. You're deferring that. Yeah.
But deferring sometimes is a good thing.
I
It's a
like
good
to
thing.
look at it as an avoidance. Not necessarily deferring, but we've avoided it for this
For
time
this year,
period.
but it's still.
And so unless we have to go do it in the 20-year period, yeah, at that point. But
just because I don't have to buy a car today because I can get my car to run another year, that still means I might have to buy a car in another year. But no, it's a good thing. I'm not saying it's not a good thing. I'm just saying that this is not 100% savings on this particular one, unless you can go a full 15 years.
Well, okay, I'll accept
Can
that.
I help you out, PK? Maxine
I'm not
Max
gonna
at
argue
DOE. So Don, one of the things is we're hoping that we can start the downblending process for the material that EM owns so that we
So you
never
will
have
not-
to do
you
that.
will never, okay.
Okay.
But it's
Thank
still
you.
not going to happen in 5 years.
Not in 5 years, but we can at least attack it.
Some of them, yeah.
Yes.
Okay.
Thank you.
Thank you.
Bobby?
Bobby Williams, CAB. Can you tell us a little bit about your first section, FY17 indirect work scope, about the drill
Can we
team
go
and
back? I'm sorry.
on page 4?
Oh, page 4? Okay.
It talks about the drill team.
Oh, okay. As far as what that included was when we have emergency type situations at the site, that was the formation of a specific emergency drill team so that they would be in place to conduct the drills so that when DHEC comes in the department, we have them graded, that we have a team that's responsible for going through and all that. But that's what that was. That was the formation of that SRNS drill team for emergency drills and things like that, or exercises that we have at the site.
So is that different from what you had in the past? You had an employee or a coordinator for each area.
You still have the
drill.
coordinator for each area, but now we have a specific team at the site level as for those site level drills that depend on the facility coordinators for information and things like that.
Okay.
And you had that, but we kind of got away from it when we started reducing our workforce. We had it, but we kind of, I shouldn't say formation, I should say we've reinforced that drill team. So that's probably a better word for it than formation.
And talk about the other 3 bullets there.
Increase the cost. Well, we had to switch over for our Microsoft license. We were using Lotus Notes, and now we're using Office 365. So that was a. So that required us to use the headquarters license. So we didn't have that in our budget. So we went and found money, and that was the way we were able to do that agreement. And the site radio system. We've been in existence since 1952, and some things don't always get upgraded as the technology is available for us. And so that we're always looking, and that was one of the things we needed to upgrade, and so we found the money to go do that this year as well. And then roof replacement. We have aging facilities. We don't necessarily have a separate pot of money to go do roof replacements, and so some things are deferred over operations, and so we tried to pull forward those roofs that were in dire need of being repaired to make sure we address them, and so that was what. And so even if there's a building in SRR, with us being the M&O contractor, we're responsible for making sure that their buildings or anyone on site, their buildings are inhabitable and they don't have leaking roofs. And that's not always, and they're always calling us, letting us know, hey, we have a roof, can we repair it, type of thing. So that's any contractor. We're responsible for all the roofs on site. Okay? Did I answer your question for you? Yes. Okay.
All right. David Vivakis.
Dave Vivakis, CAB. Question for Ms. Hightower, SRNS. On slide 2, on the focused improvement transformation, you talk about increasing value to SRS customers, plural. Who are those SRS customers?
Our main customer would be the Department of Energy, but we try to get people to understand that when you're looking at things from a holistic standpoint for processes, you have internal customers as well as external customers. So if I'm looking at, if I'm a manager and I'm going to work with workforce services to get a requisition to get a new employee, then they have to understand me as a customer and my needs. So that's the plural for the customer, internal and external customers. So that's what we're trying to increase the value, and we try to get people to understand this is not just about the Department of Energy. They are who we need to answer to, but we also need to answer to each other and be accountable to make sure. And I'm going to tell you, the number one thing that we did last year when we first started, back in 2016, when we first started doing this, it wasn't what senior staff said we needed to do, but it was what Carol Johnson felt. She kept hearing from everybody was, we have so many problems securing materials and services. So the first thing we tackled was supply chain management. And that is supply chain has customers all throughout the site. And if I can't get my resources when I need them, materials, services when I need them, then I can't get my job done. So that's that mindset is, I'm not an island. I have people that I need to answer to other than DOE. I know I need to answer to them, but I have internal customers as well that I need to answer to.
Thank you.
You're welcome.
Dawn, you got a follow-up, I believe.
Well, actually, it's a follow-up, other question. Dawn Gillis, CAB. Back on your slide 4.
Yes, ma'am.
What were the kind of things that you saved in order to do all that additional work? Like, for example, in the staffing requisition approval team to save $4.5 million. What kind of things did you do?
We did there for staffing, it's very important that when you have a requisition and you want to bring in people, And right now, we have a team called the Requisition Approval Team. They call it a RAT team. And that RAT team has to look at every requisition and decide whether it's something that we really need, or can we possibly increase the scope of some of our current workers so that we could avoid hiring that person and save money.
Oh, okay.
And through that, we saved about $4.4 million. Or if we had things where we could reassign people that were no longer needed in certain areas, if we improved them, we could reassign them. So it wasn't necessarily a body that we didn't hire. We just might have moved people around to try to save the money that wasn't needed in that particular area. But we also had to follow the rules and make sure we stayed in our different pots of money based on what the department has provided for us.
Okay, so all of those things in the dark blue column had a lot of work associated with each one of them.
Yes, and then the human resource Taleo replacement, well, that was a contract. It was like $250 for a license to maintain the Taleo, which was a commercially available performance software. And so we decided we didn't want to use that any longer, and we developed something in-house. And out of that $250,000, we saved $124,000 that was reinvestable. And we put that money into our new hire value stream analysis, because we know we needed to hire new people and bring them in as efficiently as possible. So that's what we did there.
Okay, thank you.
Okay, you're welcome.
Doug?
Doug Howard, Cap. Question, I want to go back to slide 4 and back to that communication radio system that you had. Me being a communicator in the military, I just have a couple of questions I want to ask on that. What is this radio system used for? And
we have,
do you all, I guess, communicate and discuss classified information over that?
No, no, we don't communicate and discuss classified information. We have a pager system for emergency events, and they have to page people to let them know that they're required to come in to participate in the event. And all of that was, and the reason we knew we had a problem with it, I think it was the storm, one of the storms, and we had a system where the communication was broken down because of frost at the tower that's in between the site and North Augusta. There's a tower, and it froze. So that's that radio communication system, and then we realized we needed to upgrade that system and use something. But no, none of that is for classified discussions, no. No. And then we have people who workers who go out into areas where there's no PA system that they can hear, and they have the radio system where they can communicate with the EOC and that type of thing, emergency office, and they can communicate. So that's the type of radio system we're talking about, but no classified information with that.
Thank you.
You're welcome.
Anybody else? Folks, thank you very much.
Thank you. I appreciate the time.
So y'all got a lot done today. You passed 3 new recommendations, you closed one, and you elected a new chair and vice chair. Good job. Are there any closing remarks before we hand it over to Nina to close out for the day? Nina, the show's all yours.
Good. Thank you all so much.